Uh-oh, hurricane alert! Everyone's hiding! The speed of the wind outside is more than 75 miles per hour. Seems like a lot, but this storm is moving at 400 miles per hour. Wait, do such speeds exist? Yep, but to see a storm that fast, you'll have to travel to Jupiter. So let the journey begin. The planet is huge. Almost 1,300 Earths could fit into this gas giant. It's also incredibly hot, with the temperatures reaching about 43,000 degrees Fahrenheit at the planet's core. Unfortunately, you can't land on Jupiter's surface because, well, being a gas giant, it doesn't have any solid surface. But you can go deeper into Jupiter's atmosphere. Look at these thick brown, yellow, red, and white clouds passing by. They're what make the planet look colorful and kind of striped. If you continue descending toward the center of the planet, you'll see its atmosphere, mostly made up of hydrogen and helium gas, becoming liquid. It happens because of immense atmospheric pressure. The planet's core itself is a mysterious object. Scientists still haven't figured out whether it's a molten ball of thick liquid or a solid rock 14 to 18 times the mass of Earth. Anyway, exploring Jupiter isn't the main goal of your trip. No, you've arrived here to see the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the tops of the surrounding clouds. The storm is 1.3 times wider than our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot. And it turned out that this monster of a storm goes more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere. And keep in mind that Jupiter's temperatures are minus 234 degrees Fahrenheit in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. There, the heat reached 2,400 degrees. This temperature is higher than that of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear entirely. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The change in the wind speed is no more than 1.5 miles per hour during one Earth year. It's a tiny change, but however small the difference is, it still means a lot. The wind speed at the edges of the storm can reach a mind-boggling 400 miles per hour. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. Scientists faced lots of challenges when they were trying to understand the mystery that was the Great Red Spot. It's unclear what fuels the storm. Can it be the nature of the storm's home planet? Since it's a gas giant, Jupiter doesn't have any solid ground, so there's no friction, which might be the only thing that could make the storm weaken. The hot gases in the planet's atmosphere are always moving, rising, falling, swirling, just like on our home planet, where cooler and warmer air mix and merge into one another, forming giant circling storms. Astronomers think that once, several enormous storms could have come together and created the Great Red Spot. And now, it keeps going by constantly drawing cool gases from below and hot gases from above. Plus, the storm might be absorbing other smaller vortices. This makes the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow astronomers to see what's going on in the planet's lower atmosphere. Scientists have been speculating on what may hide beneath the Great Red Spot for decades. Is it a massive volcano? Unlikely. Jupiter is mostly made up of gases, and it doesn't have a crust that could crack, letting lava escape from the planet's interior. There are also a few theories explaining why the storm has its trademark color. It varies from whitish and pale salmon to bright orange and brick red. Some scientists believe the answer lies deep below the Great Red Spot, closer to the planet's surface. A colorless layer of gas might be reacting to the UV radiation coming from the sun. This is probably what gives the storm its red color. But so far, it's just a theory. Hey, your guess is as good as mine, huh? Jupiter isn't the only planet that can boast having a giant storm. Another one, as wide as our home planet, rages on Saturn. It's called the Great White Spot. How clever! The storm has a tail of white clouds encircling the entire planet. It occurs every 30 years or so. The storm indeed starts as a spot, but then it starts stretching and stretching. Astronomers have figured out that the Great White Spot is actually a huge system of thunderstorms. At the top of the storm, lightning can flash more than 10 times per second. But the main mystery about the Great White Spot is where it gets its energy from. Some scientists think it may be powered by the sun. Others argue that the storm's cloud pattern only makes sense if there's an internal source of heat that can power the winds. Anyway, severe storms on different planets of the solar system aren't the only space mystery that makes astronomers scratch their heads. Let's move to Pluto, the largest known dwarf planet in the solar system, and explore its atmosphere. It rises really high above the surface of the planet and has more than 20 layers, all of them freezing cold and extremely condensed. By the way, our Moon also has some sort of an atmosphere. Called an exosphere, it consists of helium, neon, and argon. It's 10 trillion times less dense than Earth's atmosphere. While traveling through space, watch out for black holes. Woo! A black hole is a place where gravity is so strong that even light can't get out. But black holes can sometimes behave like a massive galactic volcano. From time to time, they flare up. Sounds like me. But instead of spewing lava, they produce enormous amounts of energy, and this phenomenon leaves gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater this event left behind could fit 15 Milky Way galaxies. Yeah, I can't get my head around that either. During your space voyage, think twice before landing on unknown planets. Otherwise, you may end up in a place like K2-141b. That's a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate, form clouds, condense, and get back to the surface as rain. But instead of water, it rains rocks. The surface of this exoplanet is covered with lava seas dozens of miles deep. The temperatures on the K2-141b reach 5,000 degrees during the day. That's toasty enough for the magma in the oceans to vaporize into the atmosphere. Then, supersonic winds, which can move at the speed of 1 mile per second, carry this rock vapor into the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. Not a vacation spot. Too hot. I'll pass. The fastest wind speed ever recorded on Earth was related to a hurricane gust. On April 10, 1996, tropical cyclone Olivia was passing by Barrow Island, Western Australia. At one moment, the storm reached the speed of a Category 4 hurricane, 254 miles per hour. That's faster than a Formula One racing car. You can probably imagine how much damage this kind of wind can cause. The only windstorm faster than that is a tornado. The air inside a whirlwind can move at a speed of 300 miles per hour. Unfortunately, there's no sure way to measure tornadic winds. Weather instruments never survived the experience. Oh, and licking your finger and sticking it up in the wind to measure speed also isn't a good idea here, unless you don't mind losing your arm, or worse. Here are some more numbers. 35 miles per hour and more, that's the speed of the average blizzard. 50 to 60 miles per hour, that's how fast a severe thunderstorm moves. More than 74 miles per hour is the speed of a powerful tropical hurricane. Up to 400 miles per hour? Wait, do such speeds exist? Yep, but you need to travel to Jupiter to see a storm that speedy. The Great Red Spot is an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the surrounding cloud tops. The storm's almost 3 times as wide as our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot. And it turned out that the monster of a storm went more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But since these measurements were most likely imprecise, the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere, and Jupiter's temperatures are minus 234 degrees Fahrenheit in its upper cloud layers. The closer it is to the core, the hotter it gets. But the highest temperatures ever recorded on the planet were in the atmosphere right above the Great Red Spot. There, the heat can reach 2,400 degrees Fahrenheit. That's hotter than lava on our planet. The storm's extreme conditions and turbulence produce gravitational and sound waves. These waves might be responsible for the superheating. The storm itself is also warmer at its bottom than at the top. If you found yourself at its center, you wouldn't be too impressed. But on the edges, the wind speed reaches 300 to 420 miles per hour. That's faster than Earth's tornadoes. Now, this will help you picture the immense force of such winds. On Earth, the wind doesn't have to be faster than 60 miles per hour to lift a person as heavy as 170 pounds from the ground. A wind as fast as 75 miles per hour can uproot large trees, peel off roofs, break windows, and turn over mobile homes. When the wind speed reaches 150, it can send cars flying. Now picture the havoc a storm as powerful as the Great Red Spot can cause on our planet. But could such an enormous anticyclone occur on Earth? Luckily, not. Our planet doesn't have the unique conditions needed for the storm to form. Scientists faced lots of challenges when they were trying to understand the mystery that was the Great Red Spot. And it was mostly the fault of the storm's home planet. It's more than 1,000 times larger than Earth and over 300 times as massive. Jupiter is a gas giant, which means it consists mostly of fill in the blank. Around the planet's core, there's an ocean of liquid hydrogen. And the atmosphere is also mostly made up of hydrogen and helium. That means Jupiter doesn't have any solid ground, the only thing that could make the storm weaken. Without any friction, the storm has already been churning for centuries. The hot gases in the planet's atmosphere are always moving, rising, falling, and swirling. Just like on our planet, when cooler and hotter gases mix and merge into one another, they form giant circling storms. Astronomers think that once, several enormous storms came together and created the Great Red Spot. And now, it keeps raging by constantly drawing cool gases from below and hot gases from above. Plus, this monster of a storm absorbs other smaller vortices. They make the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow people to see what's going on in the planet's lower atmosphere. Astronomers have been speculating on what may lie beneath the Great Red Spot for decades. Could it be a massive volcano? Unlikely. Jupiter's mostly gas. That's why it doesn't have a crust that could crack and release scorching hot stuff from the planet's interior. Several theories try to explain why the storm has its trademark color. It varies from whitish and pale salmon to orange and brick red. Some scientists believe the answer lies below the Great Red Spot, closer to the planet's surface. A colorless layer of ammonium hydrosulfide might be reacting with cosmic rays or the UV radiation coming from the sun. This somehow gives the spot its pretty red color. But so far, it's just a theory. Astronomers have been observing the Great Red Spot since the 1830s, and for the first time, the storm was spotted in 1665 and described as the permanent spot. In other words, the storm is almost 400 years old. Strangely, it's been shrinking in size since the beginning of the 21st century. In 2019, it began flaking at the edges, with smaller pieces breaking off and vanishing. If this process continues, by 2040, the Great Red Spot will become circular, or it may disappear altogether. The storm isn't only getting smaller, it's also growing taller and getting a more intense orange hue. It's not completely clear why it's happening. Might be because of a chemical reaction. It occurs when some new material rises to the top layers of the atmosphere from below. The Great Red Spot might be the most famous storm in the solar system, but it's by no means the only one. Even on Jupiter, there's a bit less known Little Red Spot, one more anticyclone but smaller in size. Well, when I say smaller, I mean the thing's not as large as its big sister, but it's still about the size of Earth. Recently, the highest wind speed inside the Little Red Spot has increased up to 400 miles per hour. A storm as wide as our planet rages on Saturn. It's called the Great White Spot. The storm has a tail of white clouds encircling the entire planet. It occurs every 30 years or so, when Saturn's northern hemisphere tilts toward the Sun. This storm indeed starts as a spot, but then it stretches in length. Astronomers have figured out that the Great White Spot is actually a huge system of thunderstorms. At the peak of the storm, lightning can flash more than 10 times per second. But the main mystery about the Great White, it's where it gets its energy from. Some scientists think it may be powered by the Sun. Others argue that the storm's cloud pattern only makes sense if there's an internal heat source that can power the winds. Great dark spots on Neptune are massive storms that form in areas with high atmospheric pressure. That's different on Earth. Here, storms appear when the pressure is low. Around the spot's edges, the wind speeds can reach 1,300 miles per hour. Astronomers have observed 6 dark spots on Neptune so far. These powerful storms get born deep in the planet's atmosphere, and the darker a storm is, the brighter the methane clouds around it are. Another monster-sized storm raging on Saturn looks pretty much like a hurricane or typhoon on our planet. It has an eye and spiraling clouds surrounding it. But compared to Earth's hurricanes, the one on the ring planet is titanic. On Saturn, the eye of the storm is up to 1,250 miles across. The bright clouds closer to the edges of the hurricane are moving at a speed of 330 miles per hour. But one of the most unusual things about this storm is its shape. It has 6 sides and is known as the hexagon. When astronomers saw the first images with the vortex, they did a double take. The thing was just too similar to our storms. And still, the one whirling on Saturn has an eye that's almost 20 times larger than any people have seen on Earth. The storm also moves 4 times faster than hurricane winds on our planet. Saturn's atmosphere has little water vapor. How the bizarre hexagon storm is getting by in such conditions is a mystery. Plus, unlike the constantly drifting hurricanes on Earth, the one on Saturn seems to have nowhere to go. For some inexplicable reason, it's stuck at the planet's North Pole.
Scientists keep finding new planets they call super-Earths. It's a class of more massive planets than Earth, but way lighter than ice giants, such as Uranus and Neptune. Super-Earths can be made of rock, gas, or a combination of these two. They are often twice or even up to 10 times bigger than the Earth. They're interesting to study, but kinda too far away from us. They're pretty common outside of our solar system, together with other interesting planets like mini Neptunes. Those can also be gas dwarfs, ice giants, or huge rocky bodies. But again, we don't have anything like that. But something we do have that those other solar systems don't? Jupiter. It's the biggest and heaviest object that orbits our sun. This king of planets possesses a powerful force to dominate our solar system. Jupiter is notorious for eating planets. A protoplanet slammed into it about 4.5 billion years ago, when Jupiter was still a young planet in its early stages. This protoplanet was 10 times heavier than Earth and was made of ice and rock. The collision was huge. Jupiter's core broke apart, and helium and hydrogen mixed with denser materials. Through time, the heavy material settled back into the dense core, which is what we see today. And if it swallowed a planet before, it might keep doing it as well. We suspect our solar system used to have many more large planets than it has now. For example, it's kinda empty around Mercury today. Similar areas around many other central stars are definitely more packed with intermediate mass planets, with the size between Earth and Neptune. Our solar system was a chaotic place at its beginnings. Young stars were surrounded by swirling disks of dust and gas, and planets would form out of that debris, something like trees when they're springing up from the ground. Small rocky planets would form in the strong heat and light close to stars, while gas giants would form farther out, where temperatures were lower, which means they could preserve more gassy materials. And even though planets in our solar system seem pretty stable and peaceful today, following their orbit, they weren't that calm before. Some planets didn't have a circular orbit. They had oblong, more eccentric paths. It took them swinging first toward their stars and then farther away. It was like they had been thrown off kilter by the gravity of other planets on their way. There's something called the grand tack theory. It explains things happening in the first few million years when our solar system was forming. At some point, Jupiter, one of the key players here, may have been pulled in closer by our central star. After that, it went back and took a huge cloud of debris. It was like a sailboat when it tacks around a buoy. This kind of messed with planets that were in the process of formation. After Saturn was fully formed, our close neighbors in the solar system cleared out a little. But if the idea about grand tack is correct, Jupiter had grabbed everything in its way, and its migrations had caused more collisions in this area. Jupiter might have delivered some of the water that now fills the oceans we have on our planet. It shepherds plenty of asteroids. From time to time, it sends some whizzing into interstellar space, or amongst the planets in our solar system. It may have even taken part in the dinosaur extinction 66 million years ago. When the huge space rock hit the Earth, it left a crater off the coast of the Yucatan Peninsula in Mexico. It all caused earthquakes, volcanic eruptions, and tsunamis that made a huge impact on all animal and plant life on Earth. No one knows where it came from. We're not even sure if it was an asteroid or a comet. One theory says it may have been a comet that came from the Oort cloud, which is made of icy debris and is located somewhere at the edge of our solar system. It could have been bumped off course by Jupiter and its powerful gravitational force. This way, our solar system was like a pinball machine, where Jupiter, the biggest planet, kicks incoming comets into orbits that send them closer to the Sun. When these comets are near the Sun, they can go through strong tidal forces that break them apart and eventually create shrapnel-like pieces of a comet. That event was a point when our mammalian ancestors started to rule. That means without Jupiter, there might not be us either, nor the Earth. It seemed like our biggest planet came swinging in, destroyed older planets, and cleared the way for smaller worlds like ours. Jupiter may have been the reason why we can't find Planet 9 right now. Scientists believe it exists, and they think it could be hiding somewhere beyond Neptune, but not Pluto. There are 3 zones in our solar system: the inner planets, outer planets, and whatever there is beyond. The mysterious planet could be the size of the Earth or Mars. It swirled among the gas giants before they eventually swept it toward the outer parts of our solar system, or even somewhere into deep space. Jupiter has stripes because of differences in temperature, atmospheric gas, and chemical composition. Scientists used to think the only reason for these different colors was the mighty atmospheric wind and material circulating between layers of the atmosphere. Now we know the light-colored stripes, or so-called zones, show us where the gas rises. When the stripes are dark-colored, they're called belts and can tell us where gas is sinking. Jupiter's moons could also be why the planet is stripy, because they're tugging on its atmospheric convection cells. At the center of Jupiter, there's a dense liquid core made of helium and metallic hydrogen, together with dissolved heavier elements. As we go further from its center, the temperature and pressure inside the planet drop off. That way, the liquid interior gives way to gases from the atmosphere. Again, mostly helium and hydrogen. No one knows how deep this liquid-gas boundary lies, but the planet is probably fully liquid a couple of thousand miles under its cloud tops. Jupiter would still be bigger than some other giants, like Saturn, if we could strip its gases. Jupiter is sometimes even called a failed star, although that's not quite correct. It's mostly made of hydrogen, like regular stars, but it's still not massive enough to start thermonuclear reactions in its core, which would eventually turn it into a real star. In theory, every object could be turned into a star if you only add enough matter to it. If there's enough mass, the temperature and internal pressure will increase and start thermonuclear reactions. So, to turn Jupiter into a star, such as the Sun, you'd have to make it 1,000 times more massive. But to form a cooler red dwarf, you'd only need 80 Jupiter masses more. That way, Jupiter won't spontaneously become a new star of our solar system. But if many space objects with similar mass collide with it, or in other words, if Jupiter eats them, then maybe. You never know. But in theory, if it could become a massive star, it would have stopped other planets from forming in stable orbits. It would have also increased the radiation that the surface of those planets get, which is why it would be really hard for life to develop in our solar system. Jupiter is the planet that spins the fastest in our solar system. It only needs 10 hours to make a full rotation on its axis, even though it's huge, more than 300 times bigger than the Earth, and 2.5 times more massive than the rest of the planets in our entire solar system together. But if it got more massive, it would shrink. More mass would make Jupiter denser, which means it would begin pulling in on itself. So it could get 4 times its mass and would still be the same size.
Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation, phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus'
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains Enceladus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus
was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contain phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. all because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick, but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that.
You're in your galactic space cruiser on your way to Outpost 52, delivering supplies for the small colony there, when alarms begin going off. You scan your displays, but something catches your eye before you can work out what's happening. You don't need a view screen, as the front section of your ship is transparent, like a one-way mirror. A colossal orange and purple cloud is sweeping towards you. There's no time to analyze it. You put the ship into a dive, as steep as it will go. The alarms go crazy, but you're too focused on getting out of danger. The ship rattles, and you think it will break up, but your ship is fast and powerful, and somehow you manage to get underneath it. You look up and see the gigantic plasma cloud go soaring past. Curiosity has bitten you, and you decide to follow it. You program your computer to analyze it. Soon the information is coming back, and you can't believe what it's telling you. This plasma cloud is a wrecker of galaxies. It and others like it have been ending galaxies before their time. You recall your studies back on Earth when you were just a young pilot. There have been studies as far back as the 21st century as to why galaxies were mysteriously ceasing the formation of new stars, causing them to end ultimately. Stars form from thick clouds of gas that have become extremely cold. They condense and, over time, collapse into solid compact matter. There's a famous photograph taken by the Hubble Space Telescope. Most people have seen it. It's called the Pillars of Creation. It's the Eagle Nebula, where stars are forming. They call these environments star nurseries. It's a pretty cute concept if you think about it. But there's a bad guy lurking, and you're following it. It's a vast star wrecker. The wrecker rushes in and sweeps the gas out of these star-forming galaxies at an accelerated rate, preventing stars from forming in the first place. It's like a giant broom. But rather than cleaning up, it's ceasing up, bringing new galaxies to a premature end. Now that you know how dangerous it is, it's best to hang back a bit. Let's see if we can see it in action from a safe distance. It had been a long-standing mystery why some galaxies don't birth new stars. The star wrecker is smart. It hangs around large galaxy clusters. There's one in particular, the Virgo cluster. This is the one that scientists studied and came across the star wrecker. The nearby Virgo cluster is 7 million light-years across and contains thousands of galaxies. When I say nearby, it's about 65 million light-years from us. Not exactly a weekend space cruise away, but it's pretty close in galactic terms. The cluster hurtles through the superheated plasma at speeds of up to 1,000,000 miles per hour. The cluster forms the basis for the large Virgo supercluster, of which the local group, where our Milky Way resides, is a member. Its proximity to us makes it easier for scientists to study. It's also one of the most extreme regions of the universe that we know of, currently. Who knows what else is out there? The Virgo cluster is also unusual, as it's still forming new stars, and we can observe them, such as in the famous Hubble nursery photo. A galaxy in this cluster is called the Messier 87. It was discovered way back in 1781 by a French astronomer named Charles Messier. It looked a bit fuzzy to him, so he called it a nebula without stars. More information on what it was couldn't be ascertained until the 1920s. Messier was well respected and in his lifetime discovered 13 comets. He was born in rural France, the 10th of 12 children. When he was 14, he witnessed a tremendous six-tailed comet in 1744. It was astonishing and was visible to the naked eye for several months. Its effects were dramatic and unusual. It was so bright that it's been recorded as the 6th brightest in history. 4 years later, young Charles saw a solar eclipse from his hometown on the 25th of July, 1748. He knew then that he wanted to explore the world of astronomy. It was meant to be. A lunar crater and an asteroid have been named after him. Nothing is mighty, however, like the Messier 87, or M87. It's a supergiant elliptical galaxy with trillions of stars. It's the second brightest galaxy within the northern Virgo cluster, making it popular amongst astronomers and amateur enthusiasts. Elliptical galaxies are older, low-mass stars with minimal star formation activity. Large numbers of globular clusters surround them. They make up roughly 10 to 15% of the Virgo supercluster. M87 has a supermassive black hole at its core. The black hole was photographed using data collected in 2017 by the Event Horizon Telescope, EHT. It was announced excitedly to the world in 2019. In March 2021, the EHT collaboration revealed a polarized-based image of the black hole for the first time. It was a pretty exciting event. It was the first time that a black hole had been captured. It happened all thanks to the Event Horizon Telescope, which is many radio observatories or radio telescope facilities around the world, all working together to produce a highly sensitive and high-resolution telescope. Another array of telescopes in Chile is called the Atacama Large Millimeter Submillimeter Array, ALMA. They captured high-resolution images of the 51 significant galaxies in the Virgo cluster. That's part of how we know what we know. M87 and other galaxies don't appear to be doing a lot to the naked eye. In fact, in a typical human lifetime, they barely move at all. Yet they are made up of gas, dust, and other objects that move through space at high speeds. They move when affected by the gravity of other galaxies, or dark matter, a mysterious entity that is 5 times more common than ordinary matter. Many galaxies, including our own, are believed to have a halo of dark matter surrounding them. The dark matter can pull more significantly on the smaller galaxies outside the clusters. As the galaxy gets dragged around through space, the star wrecker may come across. Giant clouds of intergalactic plasma, a form of electric gas, can behave like an atmosphere and drain the gas inside the galaxy. It sweeps out the gas inside the galaxy, stripping it of what it needs to make stars. It's hard to grasp the scale of this sort of activity, but that's what scientists now believe has been occurring to some galaxies or the nebulae without stars, as Charles Messier saw it. Now, let's park our space cruiser here and watch this thing in action. What we've been calling star wrecking is known as gas stripping. It's one of the most spectacular and violent external events in space. A scientist from the National Research Council of Canada said that galaxies are moving so fast through hot plasma in the cluster that a vast quantity of cold molecular gas is stripped from the galaxy. It's as though the gas is being swept away by a giant cosmic industrial blower. It's not the sort of clean-out we want to happen in our galaxy. You observe it in action. You're impressed, but equally respectful of its great power. The gas stripping, also known as ram pressure stripping, travels through many galaxies and removes a star-forming gas. The process is very efficient. The gas is behaving differently from the clouds in our galaxy. They aren't forming as many stars as they are in ours. A 21st century study found that the same process happens in smaller groups of only a few galaxies, with much less dark matter. The study looked at a staggering 10,567 satellite galaxies. These are galaxies that exist beyond the enormous galaxy clusters. Most galaxies in the universe exist in between 2 and 100 galaxies. They were able to study such a large number by using stacking. It makes it possible to learn about a collection of faint objects by combining all the information from the objects and making an average characteristic. They ultimately determined that gas stripping, or star wrecking, is potentially the main way that galaxies, predominantly star formation, are shut down by their surroundings. Pretty unfortunate to have such a nasty neighbor. So, now that your curiosity has been satisfied, it's best to leave this plasma cloud and get on with your journey to Outpost 52. You're going to be late now and could be in a whole lot of trouble. While the cruiser turns around, we'll head back to Earth. And back in time, back to 1744, to that night in rural France, where a teenager stood outside, marveling at the night sky and the spectacular vista of the six-tailed comet. And from that moment, was inspired to begin a lifelong quest based on a single question. Perhaps the ultimate of all. What's out there? You're standing in a room full of explosive gas. One spark could cause an explosion so powerful that all the windows and doors would be just blown out with a huge column of fire. And you're holding a match. You need a bigger target than this room. How about the largest room of explosive gas in our entire solar system? Meet Jupiter. It's the 5th planet from the Sun, and the largest one in our system. It's 11 times the width of Earth, and almost 2.5 times heavier than all the other planets in our solar system combined. If we put Jupiter on the scales, we would need about 317 Earths to balance it. But most importantly, it has a lot of methane in its atmosphere. It's the gas we use in our kitchen, or fill up our car with, and it burns just fine. More importantly, there's metallic hydrogen. In its normal state, hydrogen is the lightest element in the universe. But on Jupiter, it's at great pressure, more than 400 million atmospheres. By comparison, on Earth, you feel the pressure of 1 atmosphere. So multiply that by 400 million, and hydrogen is compressed so much that it looks like liquid metal. Metallic hydrogen can be a great fuel. It'll give off 20 times more energy than burning ordinary hydrogen. So you and your match can have great fun out there. Okay, here we go. The first problem is distance. Jupiter is only 1 planet away from us, but the path is also blocked by the asteroid belt behind Mars. It's full of giant rock debris. On average, each asteroid could be as wide as the distance from Los Angeles to Las Vegas. There's rocks the size of an entire state. And the biggest asteroid of them all is Ceres. It's almost as wide as Alaska. It's even considered a dwarf planet. And this dangerous journey to Jupiter takes about 650 days. That's almost 2 years of boredom inside a spaceship. By comparison, the longest time astronauts have spent aboard a spaceship is 84 days. But we'll let you take your favorite DVD collection and a couple bags of popcorn. At the end of the day, you'll be able to get some sleep after a hard day at work. Fast forward 2 years into the future, and you've arrived at your destination. You're already imagining lighting a match at the surface of Jupiter, exploding it like a balloon. Oh, be careful when you get close to it. Because of Jupiter's great weight, it has a strong gravitational force, about 3 times stronger than back home on Earth. The closer you get to its surface, the weaker you feel, and you can even barely stand on your feet. The maximum weight you can lift here is also 3 times less, and even a match you're holding in your hand already feels heavier. If you try to jump up, you need more effort. Actually, you can't even do that because Jupiter is a gas giant. That means it has no solid surface. Theoretically, the deeper you dive into these clouds, the more pressure you'll feel. Gradually, the clouds and gases thicken and form a kind of liquid. But you don't have to dive that deep. Methane is a light gas, and it's closer to the surface. So, this is the moment of truth. You take a match, you flick it on the box, and nothing happens. Well, let's give it a couple more tries. Second match. Third. Nothing works. Okay, you've got a gas burner in your backpack. You unscrew the valve to maximum, and nothing happens again. Well, that's because it takes 3 components to start the combustion process. The first is fuel. Luckily, there's enough methane and metallic hydrogen on Jupiter to blow up the whole planet in a matter of seconds. The second component is the ignition source. It's the initial force that will start the combustion process. It could be a spark, an electrical discharge, or a match like the one you have in your hand. And the last ingredient is oxygen. Yes, the same oxygen that we breathe. It's just as important to fire as the fuel itself. For an experiment, try lighting a small candle. Now cover it with a glass. You see how the fire keeps burning for a few seconds and then goes out? The fuel is still there, but the fire has used up all the oxygen inside the glass, and the burning process is over. The same thing happens on Jupiter. There just can't be fire, simply because there's no oxygen. And you didn't even have to fly there to find that out. From Earth, we can see hundreds of thousands of little meteorites falling on Jupiter. The asteroid belt next to it is to blame for this. When they hit its atmosphere, they start to burn, and that doesn't instantly blow up the entire planet. But don't be upset. There's still a way to ignite this gas giant planet. All you have to do is trigger a thermonuclear chain reaction on the planet. Then, there'll be an explosion so powerful, it'll be visible from Earth, and it will be like the birth of a new star. To do that, we need to detonate a nuclear reactor, like the ones that give us electricity here on Earth. In fact, we'd have to send everything we have to Jupiter, but even that won't do the trick. Big asteroids, when they hit the planet, cause a much bigger explosion. In 2009, a meteorite the size of 5 soccer fields hit Jupiter. It caused an explosion of 5 billion tons of TNT. This incident left a dark spot the size of the Pacific Ocean. And an even bigger explosion happened there in 1994. After that collision, there was a giant spot on Jupiter, almost the size of our planet. But strong winds and storms quickly began to sweep away the traces of the explosion. After a few weeks, Jupiter looked like normal. The problem is that our attempts to blow up the gas giant took place on the planet's surface. We need to plant a charge the size of the moon, deep below. A massive explosion will cause a thermonuclear reaction and cause the metallic hydrogen to detonate. The explosive process is set, and within seconds, Jupiter explodes like a giant balloon. But this spectacle will be the last one that humanity ever sees. The explosion would disturb the stable orbits of Earth and the other planets. The trajectory of Earth around the Sun might change, and we may see the dawn not in the east, but on any other side of the world. When the strong wind from the explosion reaches the Earth, it'll start scraping our atmosphere. Soon, our planet will lose its ozone layer. It was our shield that protected us from solar radiation. In such a situation, we'll have to hide underground for the rest of our lives. But even this can't protect us. Before long, the Earth will be showered with thousands of meteorites. Jupiter was so heavy that it held the asteroid belt in place. Without it, the asteroids would start flying towards us. Earth would feel a constant meteor shower. But there would be no one left on Earth to observe it anymore. Jupiter's explosion can be compared to a supernova. In fact, Jupiter is practically a star. If it were just a little bigger and heavier, it would start to shrink. The intense pressure on the planet's core would start thermonuclear reactions. Eventually, Jupiter will have turned into a brown dwarf, and it would be 50 times heavier than it is now. But because it doesn't have enough weight to do that, Jupiter is sometimes called a failed star. Well, maybe we should visit other gas planets in our solar system and try to light our match there. Saturn. Saturn's atmosphere is similar to Jupiter, but there's no oxygen for combustion there either. So all you have to do is admire the planet's beautiful rings and move on. Well, Uranus and Neptune are much smaller, and they don't have metallic hydrogen, so their explosion wouldn't be as strong. But you still wouldn't be able to ignite them with a match, because there's no atmosphere full of oxygen. But there is one planet where you could light a fire with your match. It's GJ1132b, and it's 39 light-years away. Scientists think it might have oxygen on it, although it's not a gas giant that has combustible gases in its atmosphere. But you can still sit on its rocky ground and make a fire to admire the unusual sunset.
Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. And it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas? And where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
Bang! Another hit on Jupiter. Let's see. Gas giant, the largest planet in the solar system, 318 times bigger than the Earth, 2.5 times bigger than the rest of the planets in the solar system put together. One more interesting thing. If it got any bigger, it would actually become smaller. You see, with more mass, the planet would be denser. That would cause Jupiter to start pulling in on itself. Scientists say Jupiter could have 4 times greater mass, but still keep the same size. It takes 10 hours to make a full rotation on its axis. It's the fastest spinning planet in our solar system and gets hit by so many space objects all the time. This was discovered by amateur astronomers observing Jupiter and saw some unusual flash at the planet's surface. Impact events cause flashes like that, and for some reason, Jupiter gets more impacts than other planets. In 1994, astronomers discovered Shoemaker-Levy 9, a comet that broke apart and collided with the gas giant. The original comet was approximately the size of one that erased the dinosaurs. However, this asteroid fell apart into more than 20 fragments. They darkened the planet's surface, and it remained like that for months. 15 years later, in 2009, astronomers saw a black spot on Jupiter, the size of Earth. It was the result of an asteroid around 650 to 1,650 feet in length. The biggest asteroid recorded on Earth hit the area of Tunguska, Russia in 1908. This caused a massive explosion, even though no one ever found a crater. So, why is Jupiter the target for so many space objects? Asteroids and comets that pass by Earth and Jupiter go almost at the same speed. The number density of the space object that may interact is almost the same too. But the cross-section of what they might hit is very different. Jupiter has 11 times the diameter of our planet, which means it has around 125 times the cross-section. The more massive some planet is, the stronger its gravitational attraction. So, it will entice some space objects drifting by. Our gravitational field is weaker than Jupiter's. If some object passes near us moving at a speed of 22,300 miles per hour or less, our gravitation will attract it. Asteroids and comets usually move at bigger speeds. Jupiter attracts most of the comets and asteroids passing by. If our planet was hit by such big objects as frequently as Jupiter, we'd have extinction like with dinosaurs thousands of times more often. In 2020, scientists found there was an unusual asteroid in the orbit of Venus, the first one there. The size of a small mountain and rich in minerals we can find in Earth's deep rocks. They even think it could be a clue to a bigger set of asteroids created when our solar system was forming. That's not the only mystery around Venus. The planet has insanely violent winds that drive clouds and storms around the planet at speeds greater than 220 miles per hour. That's 60 times faster than Venus itself rotates. Also, scientists are still not sure what happened with its oceans. They believe since the planet is so close to the Sun, the water evaporated and went into the atmosphere as steam. It trapped heat coming from the Sun, heat that would have vaporized more and more water over time. Venus probably had an environment like on Earth, but a very long time ago. The theory says many comets and asteroids were slamming into Venus. Billions of the planet's pieces were flying all around. Some may have even crashed into Earth's moon. Pieces that slammed into our planet are probably buried very deep, since we have greater geological activity than the Moon. Uranus also had a collision, but a more serious one than asteroids. The rest of the planets in our solar system mostly have an axis of rotation that kind of points up from the elliptical plane. Uranus is tilted, lying on the side, so a season there lasts 42 years, when either its south or the North Pole is pointed at the Sun. Most of the planets also rotate counterclockwise when you see them from above our solar system. Venus does the opposite, which means maybe it was kicked off axis a long time ago. Uranus may have collided with the other space body millions of years ago. When our solar system was still very young, the orbital configuration of Saturn and Jupiter may have crossed. Their gravitational forces kind of created orbital momentum and transferred it to Uranus. That knocked it off axis. Millions of asteroids orbit the Sun, and not so many pass by Earth from time to time, so we don't have some dangerous space bodies coming toward us. The plan is to visit Mars in the 2030s, and scientists hope Mars won't be a target of some bigger space bodies. New craters are formed on the red planet every 1 to 2 days. They can be 13 feet across, which means they could have been formed by objects that are the size of a soccer ball. Since the atmosphere there is thinner than ours, smaller bodies can enter easier. Most of the Martian north is smooth lowlands. The south is higher, full of craters, and the planet's interior has a surprising amount of rare metals. The theory says this is because a big celestial body collided with Mars and tore away a part of its northern half. Debris from that asteroid circled the planet and then mixed into 2 small moons that orbit Mars. We also have some Mars rocks on Earth, found in the Sahara Desert, Antarctica, and some other places across the globe. Some of these rocks have gas that's chemically the same as the atmosphere on Mars. Rocks probably came due to a big explosion that happened when some larger asteroid or meteor that was ejected from Mars and landed on our planet. Mercury also has a thin atmosphere, so there are many smaller strikes there. Imagine waking up, going to your window, and see there are micrometeor showers every morning, which is something that happens on Mercury. This strange weather pattern shapes its atmosphere, called an exosphere. Mercury is so dense, its heavy iron core accounts for 2/3 of its total mass. Scientists think it could have been bigger in the past, but many collisions got the surface sort of scraped off. It's been constantly bombarded by rocks from space that left marks with craters. Plains on its surface seem to have been created because of volcanic lava spilling over the surface and then dried smooth. Many craters are filled with such a material, which means there's one more thing that rocked Mercury's world: volcanoes. There's an unusual group of asteroids discovered near Neptune. Wide range in sizes, from big metropolitan areas to tiny pebbles. They are thought to come from an asteroid group called the Kuiper Belt. It makes a ring well beyond Neptune. But these new asteroids have different colors than the Kuiper Belt. They're so far away from the Sun, their surface was supposed to stay almost pristine, but they have a similar color to those sun-baked asteroids around Jupiter. Like the rest of the planets, Neptune gets heat from the Sun. But there's something mysterious inside the planet that makes it generate more heat than it gets. This affects its weather, and Neptune has the weirdest weather in the whole solar system. Massive storms, insanely high winds, cirrus-like clouds that rapidly change all the time. There are dark spots in its atmosphere. They come and go. We receive 1,000 times more sunlight than Neptune. Gas giants like Saturn and Jupiter can protect our planet from asteroids. Without them, the big impacts that created enough debris to form both moons and other planets would happen more often. There's a huge asteroid going around Saturn, which could be a potential flyby by 2031, more than 10 times bigger than the asteroid that erased the dinosaurs. Titan, one of the moons orbiting Saturn, 80% more massive than our moon, is actually the only moon in our solar system that has an atmosphere. It's 1.5 times thicker than ours and consists mainly of nitrogen, like our atmosphere. No one knows where all that nitrogen came from. However, unlike Saturn and most of the other places in our solar system, its moon has a real potential to host life.
Enceladus. Saturn's ocean-covered moon spews water into space non-stop. The liquid leaves the insides of the moon through fractures in its icy crust. In the mid-2000s, the Cassini spacecraft analyzed the composition of these jets and spotted molecules that included ammonia and carbon dioxide. Both compounds are crucial for the existence of life on Earth. But recently, scientists have made another analysis of the Cassini samples. And this study has revealed a great chemical diversity of Enceladus. It makes this small icy moon one of the top candidates for finding life in the solar system. In an attempt to find out the true chemical makeup of the moon, researchers at NASA examined the data collected in 2001 and 2012 again. All this information was gathered by NASA's Cassini-Huygens mission. It flew a spacecraft through the impressive water plumes of Saturn's moon many times. The samples were analyzed by a special instrument identifying compounds by their molecular weight. This instrument is called a mass spectrometer, and Cassini had one on board. The initial analysis showed that the jets contained 5 types of molecules: water, carbon dioxide, ammonia, methane, and molecular hydrogen. But later, experts spotted a few bigger and heavier compounds, including ethane and hydrogen cyanide, as well as traces of methanol. The initial Cassini analysis didn't show these compounds because the equipment on board the spacecraft wasn't capable of identifying them. That's why it came as a surprise that Saturn's small moons could be so chemically active and able to produce heavy molecules. Together with previously found components like water and ammonia, the newly discovered molecules might serve as fuel and building blocks for microbes, which in turn means that they could probably support an independent origin of life. It's one of the reasons why, after the discovery of its oceans, Enceladus has been one of the main targets in the search for extraterrestrial life. The molecules might be mixing together through the hydrothermal activity on the moon's seafloor, creating a habitable environment where life could appear. So far, scientists haven't found any evidence that could indicate that such a process has actually been going on. Plus, no one knows yet how the erupting water makes its way through the icy shell of the moon. Still, the most recent findings might help ongoing and planned missions exploring other ocean worlds similar to Enceladus. One of such worlds is Jupiter's watery moon Europa. This place is likely to have the same properties as Saturn's moon. Hopefully, we'll get the answers to these questions soon, with the help of the European Space Agency's Jupiter Icy Moons Explorer spacecraft. At the moment, it's on its way to the Jupiter system. But then another question might arise. If we found the conditions where life can originate and even thrive, can't this fact already be proof of the existence of extraterrestrial life? Doesn't it mean that life must be abundant in the universe? Then why haven't we come across other species yet? The answers to this paradox vary from optimistic to downright terrifying. It might be because we haven't been looking long enough, or maybe we haven't been emitting enough traceable signatures for other civilizations to find us, or perhaps no species have ever made it to the point where they could come into contact with other civilizations. There's also the frightening dark forest hypothesis. It's a theory claiming that loads of alien civilizations exist throughout the universe, but they are all silent and hostile. They try to maintain their undetectability for fear of getting destroyed by another unfriendly species. So, following this hypothesis, we can presume that any spacefaring civilization must view other intelligent forms of life as an inevitable threat, and the best course of action is to hide its existence altogether. This makes the cosmic electromagnetic spectrum eerily quiet, with no evidence of any intelligent extraterrestrial life. This way, the universe can be compared to a dark forest filled with armed hunters wandering among trees like ghosts.
So Mars has two moons, Phobos and Deimos. And apart from the bizarre shape, there's nothing remarkable about them, except for one thing. Not so long ago, scientists discovered a strange phenomenon on the surface of Phobos, and they still can't find any explanation for it. What is this phenomenon, and what does it tell us about the history of our solar system? Let's find out. American astronomer Asaph Hall discovered Phobos and Deimos back in 1877. Did you know that all the planets in our solar system are named after Greek and Roman deities? For example, Mars or Ares is the famous deity of war. That's why the satellites of this red planet were named after the sons of Ares, Phobos and Deimos. These beautiful names actually have creepy meanings: fear and horror. In 1971, NASA's Mariner 9 telescope took the first pictures. That's how we found out that these guys weren't at all like our moon. They had this weird shape, a strange and unstable orbit. Moreover, there are no other moons in the solar system that move as close to their parent planet as these two. Well, they are its sons after all. But even though they are very close to Mars, if you were standing on the surface of the red planet, you would hardly be able to see them. That's because the curvature of Mars hides Phobos and Deimos from view. Even if you were somewhere on the equator, Phobos would look like an ordinary asteroid to you, and Deimos would look like a star. All because these satellites are basically crumbs compared to our moon. They're the smallest and least bright moons in the entire solar system, which is ironic considering their mighty names. Anyway, it seems that everything should be pretty clear with these two satellites. But nope, there's a problem. You see, scientists reconstruct the history of space based on the traces found on different space objects. Dents, scratches, cracks, all these things can tell us what happened billions of years ago. For a long time, scientists were sure that, just like their Greek prototypes, Phobos and Deimos were twins. But then, NASA's Viking orbiter took new photos of the satellites, and that's when they discovered a significant difference between the two. The entire surface of Phobos was covered with huge grooves. Those were a series of long, deep pits stretching from one end of Phobos to the other. You may say, what's the big deal? All space objects have this kind of stuff on them. And yeah, there are other satellites with similar grooves and scratches, but none of them has as many as Phobos. It's completely covered in grooves, and they're huge, up to 12 miles long and 660 feet wide. And that's not all. Some of these grooves intersect with others. This means that Phobos has experienced not one, but many traumatic events. But what exactly happened to it? Actually, scientists are still not completely sure. However, they have a few ideas, and these theories can tell us not only about the past of Phobos, but also predict its future. Theory 1. Asteroid impact. Well, the first suspect is quite obvious. There's a large, almost 6-mile wide crater on Phobos. It's called Angeline Stickney. It was named after the wife of Asaph Hall, the scientist who discovered the satellites. Adorable. So that's what the first theory sounds like. Once upon a time, an astronomical body crashed into Phobos. The impact was so strong that it left a large crater. And the effect of the collision left a bunch of grooves everywhere on Phobos. It sounds logical at first. However, scientists have noticed a flaw in this theory. They learned that these grooves actually formed not inside the crater, but next to it. So it wasn't a collision that created them. Besides, what about those grooves that intersect with the others? Or is it just a big cosmic coincidence? Well, the search for truth continued. Theory 2. It's all because of space debris. Yes, there's a difference between these two theories. In this case, the grooves aren't a direct consequence of the collision. Rather, it goes something like this. Something crashed into Phobos. This impact caused a bunch of rocks to be thrown into space. Some of them were lost in the universe forever, but others were small enough to be pulled back to Phobos. Passing next to the moon at a steep angle, they would crash into it, jumping away, and so on. And since the gravity of Phobos is very weak, perhaps they couldn't stick to it. In other words, these rocks were continuously pulled toward and pushed off of the satellite for many, many years. This theory explains the intersecting grooves. It's because the rocks were constantly falling into those places. It sounds quite logical, but there's another problem. We don't see any boulders on Mars or on the surface of its moons. But all this debris was supposed to get trapped by gravity and remain somewhere in the planet's orbit. This, or simply become part of Phobos. In other words, if this were true, we'd find evidence of this theory under layers of dust. But that didn't happen, so this explanation didn't satisfy astronomers either. Therefore, they continued to look for the culprit. Maybe the grooves have nothing to do with Stickney Crater at all. Maybe the real culprit is something else, something even more powerful. Could it be Mars itself? Theory 3. Mars is a twist villain. The previous theories imply that Phobos and Deimos were originally pieces of Mars. Like once upon a time they broke away from it and became satellites, just like our moon. But what if that wasn't the case? Observations made by NASA's Mars Global Surveyor show that Phobos and Deimos are made up of elements which are mainly found in meteorites and asteroids. So, what if Phobos and Deimos are asteroids? There's an asteroid belt between Mars and Jupiter. Given the size, shape, and composition of Phobos and Deimos, scientists have suggested that once upon a time they belonged to this belt. However, one day they flew out of it, and then gravity pulled them to Mars. This phenomenon is called asteroid capture. It's very strange though. Yeah, the asteroid capture isn't uncommon, but these two have been flying next to Mars for what, billions of years? It's weird that their orbits have remained the same. In addition, the atmosphere of Mars is very rarefied, and because of this, it could hardly capture any asteroids. In theory, they should have separated from Mars at the first opportunity. However, this didn't happen. It means that somehow they got stuck, and Mars immediately began to destroy them. Yep, an unexpected twist. In this version, Mars turns out to be a villain. By studying the past, we've found some evidence of future crimes. The mysterious grooves of Phobos could be caused by tidal forces between Mars and Phobos. The Moon and Earth also exchange these, slightly distorting each other. But since Phobos is much closer to Mars, the impact of gravitational forces is much stronger. In other words, the gravity of Mars is gradually destroying Phobos. Every 100 years, the satellite gets 0.7 inches closer to Mars. It also shrinks as much as 6.5 feet, becoming even more fragile and weaker. The smaller it gets, the more the tidal forces impact it, creating strange grooves and scratches on Phobos. Yep, somewhere in 30 to 50 million years, Phobos will either collide with Mars or disintegrate and turn into a bunch of small rocks. And then Mars will also have rings, like Saturn and Neptune. That's why Phobos is called the doomed Martian moon. Anyway, these are all only theories. But the dramatic backstory of Phobos gives us an idea of how dynamic extraterrestrial objects can be. The more we learn about them, the more we discover about the secrets of the origin of not only Mars, but also other objects in our solar system. If one day we really colonize Mars, studying its moons can help us a lot. Let's hope that the upcoming MMX mission will reveal some of the most exciting secrets Mars's moons are hiding.
Look up. Find that little yellow dot. That's Titan. It's Saturn's largest moon. and the second largest moon in our whole solar system. And it might be the only place in our solar system where there's liquid water, besides Earth. Plus, it has an atmosphere that serves as a shield against solar radiation and cosmic rays, just like Earth. If life was a house, Titan would have a lot of the bricks you'd need to build it. Strap in, you're heading over there. It takes a long time to get to Titan, but you know, the magic of YouTube. Here it is, a bit bigger than our moon and a whole lot heavier. It's even bigger than Mercury. That means its gravity is still pretty weak. You'll feel 7 times lighter here than on Earth. At the local gym back home, you can lift 150 pounds. On Titan, you can lift more than 1,000. Ha! Looking good. The surface is mostly made up of ice. It has small mountains, craters, and a few cryovolcanoes. Basically, the same as a regular volcano, but instead of lava, this beast spits out water, ice, ammonia, and methane. There are lakes and clouds, kind of like a canyon would look like on Earth. But here, there's only a tiny difference. Everything is covered in thick fog, and sometimes it hails frozen methane. On Earth, we use methane as fuel because it burns. But on Titan, there's no oxygen. Can't get a fire going on this hunk of rock. No oxygen means you need to put on an oxygen mask, but you don't have to wear a whole spacesuit like on our moon. Titan has a stronger atmosphere. But you packed a sweatshirt, right? It's gonna get pretty cold soon, like negative 300 degrees cold. The coldest it ever got on Earth was negative 128, and that was right at the South Pole. It's so cold because it's so far from the sun, almost 900 million miles. Anyway, that dense fog and atmosphere stop the sun's rays from warming the surface. Sounds kind of extreme, but so is life. It can survive almost anywhere. Take the bacteria Dano, some long Latin word. It can survive radiation and extremely low temperatures. It even survived a whole year in outer space, on the outside of the International Space Station. Titan would be a piece of cake compared to that, especially if we drilled down a bit. Many scientists believe there's a whole ocean under the surface of Titan. Saturn's gravity gives Titan's core a little heat boost. Plus, there's ammonia in that ocean. It's like Titan's version of antifreeze. As long as the water stays liquid, life's got a pretty strong chance of success. So what's down there? Scientists have actually found real evidence that Titan might already have life on it. Here, check out this microscope. This is C3H2. It was discovered by this weird group of antenna things living in the desert in Chile. It used 66 antennas, all pointed at the same place in the sky. This C3H2 molecule can act as a building block for DNA, the code of life. Some people think that these molecules were around on our planet billions of years ago, just when life began. Scientists also checked it out firsthand with a probe that actually landed on Titan. Turns out those desert antenna things were right. Titan shot to the top of the list of places we could one day live on. Sorry, Mars. NASA has a new project, the Dragonfly mission. They're gonna send a drone out there and explore Titan even more. The mission's still about 6 years away, and the rocket will reach Saturn's moon 9 years after that. So we're gonna have to wait a while before we pack up and move to Titan. After the Dragonfly drone lands on Titan's surface, it's going to whiz around like a sort of double helicopter. It's going to have 8 propellers, 3 feet wide. Since there's weak gravity, that's more than enough to give the drone good cruising speed. It'll be able to fly about 2 miles straight up and take off and land vertically, like a regular helicopter. The main problem with the whole thing is the drone's batteries. Scientists invented a generator that converts thermal radiation energy into electrical energy, whatever that means. One battery charge should be enough for several hours of continuous flight. The Dragonfly is going to be carrying a lot of research equipment, so it's not like those drones people fly in the park on a Sunday. It's going to weigh about as much as 3 ostriches. It's going to have 2 drills, a bunch of sensors, a spectro thing to find out what chemicals are lying around, and it's also going to have its own weather channel with a ton of instruments to measure temperature and clouds and stuff. And like any gadget nowadays, it has a camera on it.
Get ready for some beautiful pics of Titan's epic landscape.
Nighttime on Titan lasts about 8 Earth days. That's when the drone's going to be relaxing on the surface, recharging and analyzing samples. That's a long time, but it's actually a good thing. Titan's distance from Earth causes a bit of a problem, a delay in communication. When they send the Dragonfly a signal from Mission Control, it has to fly halfway across the solar system. It takes over an hour. In contrast, the signal delay to Mars can be as little as 10 minutes, and the signal delay to the Moon is only about a second. Scientists expect Dragonfly to provide more information about whether we can live on Titan or not. Some experts hope to find a primordial soup there. It's a whole mush of stuff needed to make life. We had that same soup on Earth about 4 billion years ago, and every single living organism that ever existed evolved from this mush of organic elements. If the Dragonfly project's a slam dunk, and Titan does turn out to be habitable, it'll have one more mission, to find a nice place for us to settle down in. But creating a self-sustaining colony on another planet would definitely be the hardest thing humans have ever done. First hurdle, energy production. Probably some sort of nuclear power plant. Then comes shelter, for humans and their machines. Those new Titan buildings will have to protect us from the extreme cold and bad weather. Then, drinking water and oxygen. We'd need to invent a way of collecting or engineering both. Then, greenhouses for growing food. We'd also need to mine fuel for transportation. Luckily, Titan's packed full of methane, which is great for fuel. One huge problem, gravity. Because it's so weak on Titan, whoever lives there could lose a lot of muscle mass, making it hard to work and even just live. And there are those pesky cryovolcanoes shooting stuff out at random times. Or maybe we'd need a more drastic, daring idea. How about changing Titan's atmosphere so we can breathe on it and not have to wear about 100 hats and gloves? To do this, we'd need to terraform Titan's surface for a long time. Titan's atmosphere needs to be enriched with oxygen for us to breathe, and it would be great if it was a bit warmer. The next step is to create a biosphere, which means plants. We could turn Titan into a blooming jungle with plants brought over from Earth. But because of pressure and gravity, they'd look completely different from Earth plants. They might all grow super tall, or maybe they'd all shrink down to mini size. We really don't know. First things first, we need to make sure that life is even possible on Titan. Scientists recently thought there might be life on Venus. It's sort of the same size as Earth, and scientists even call it Earth's twin sister. They discovered a gas on Venus, phosphine. Supposedly, it was made by living organisms. Turns out it wasn't true. Well, not really. There is some phosphine floating around, but way less than we first thought. Look, science on other planets is super hard, people. We're always making mistakes like that.
Picture a tiger. Tigers are known for their beautiful stripes, which they always keep the same. However, imagine if the tiger's stripes could change their size, position, and colors from time to time. Magical, right? But that's exactly what happens with one Titan of our solar system, Jupiter. Why and how? Well, astronomers might just have the answer, so let's see. Jupiter is a huge and fascinating planet. When you're looking at its picture from far away, it's like seeing a beautiful sunrise. Here we have an entire palette, from creamy pale yellows to caramel browns, with even some blue shades. Jupiter is a fascinating place made mostly of hydrogen and helium, just like our Sun. However, it didn't gather enough stuff during its formation to become a star. Instead, it became a colossal ball of gas that could fit more than 1,300 Earths inside. Jupiter has these interesting patterns of dark and light clouds that go around the planet in alternating bands, like giant stripes. These dark stripes are called belts, and lighter ones are called zones. Actually, it's not unique in this. Earth and Jupiter both have these cool patterns in their atmospheres. It's just that Earth has a few of them, but Jupiter has a lot more. Why are these belts brown and beige? Those can be explained by the combination of hydrogen, helium, and other trace elements in the planet's atmosphere. It's like mixing different colors of paint to create new shades. These belts create beautiful patterns across the planet's surface. Now, because Jupiter has such a massive atmosphere and a weather system similar to Earth's, it experiences some extraordinary storms. So even though these stripes may look calm and peaceful, they're actually part of a wild weather system. It's like a never-ending storm party happening there. These belts and zones move in opposite directions around the planet. The belts go against Jupiter's rotation, like going against the flow, while the zones go with it, joining the dance. And not only do they move in different directions, but they also exist at different heights in the planet's atmosphere. The belts are like regions where things are rising up, like bubbles in a fizzy drink. So the cloud tops in the belts are higher up in the sky compared to the cloud tops in the zones, which are more like sinking areas. So, even though Earth and Jupiter have this similarity, their weather is completely different. It's like comparing apples and oranges. One of the most famous storms on Jupiter is the Great Red Spot. But why is it red? Well, that's a bit of a mystery. Scientists think that the storm sits at a higher altitude than the rest of the atmosphere. This means it gets a stronger dose of sunlight. Imagine standing on a hilltop where the sun shines brighter on you compared to the surroundings. In a similar way, the Great Red Spot gets more radiation from the sun. The storm also contains some special chemicals in its clouds, like ammonia and acetylene. When these chemicals receive that extra radiation, they react in a unique way, giving the storm its distinct red color. It's like a special effect in a cosmic theater. Anyway, the stripes look pretty cool and all. But what's the big mystery around them? Well, you see, one day scientists decided to look at data from deep inside Jupiter, about 30 miles below the surface. And after peeking in Jupiter's secrets, they noticed something strange. When they looked at Jupiter using a special type of light called infrared, the colors of its stripes actually switched around. The light bands that were pale and creamy in normal pictures become dark in the infrared view. The dark bands that were belts before now shined brightly in the infrared. This suggests something interesting. The belts on Jupiter have thinner cloud coverings compared to the zones. It's like the belts are wearing sheer, see-through outfits, while the zones have thicker clouds, like fluffy jackets. So, what we see as dark bands in normal pictures turn out to be bright in the infrared, hinting that these belts have less cloud stuff blocking the light. But here's the most strange part. Every few years, something changes. It's like the weather on Jupiter goes through a wild roller coaster ride. The colors of the belts can change, and sometimes the whole weather pattern becomes a bit crazy for a while. Scientists have been scratching their heads, trying to figure out why this happens. So they've decided to use a special spacecraft called Juno to investigate this. Since 2016, Juno has been gathering a lot of information about Jupiter, like a spy collecting clues. One of the things Juno has been looking at is Jupiter's magnetic field. Just like Earth, Jupiter has a magnetic field. It's like an invisible bubble that surrounds the planet, extending to space. This magnetic field is really important because it protects the planet and everything on it. It acts like a shield against harmful particles from space, like those coming from the sun. But Jupiter's way bigger than us, so his protective shield is much stronger. Magnetic fields are generated by something called a dynamo, which is like a big swirling conducting fluid inside the planet. This fluid moves around and rotates, kind of like a dance party happening deep within the planet. So, scientists have been looking at the data collected by Juno over the years and noticed something interesting. Jupiter's magnetic field has its own little motions, kind of like when you see waves in the ocean. Scientists call these motions torsional oscillations, which is just a fancy way of saying wave-like movements. It's like Jupiter is doing its own magnetic dance. Now let's imagine that Jupiter's insides are like a giant pot of boiling soup. Deep within Jupiter, there are slow currents that carry heat upwards, just like a conveyor belt. This heat eventually reaches the upper part where we see the clouds. But here's where things get interesting. Imagine someone starts stirring the soup really fast with a spoon. Those wavy magnetic movements, the torsional oscillations, act just like that spoon. They create a disturbance that messes up the slow currents. Now this disruption has a big impact on Jupiter's weather. It's like turning up the heat in the kitchen and changing the way the soup cooks. The patterns of rising and sinking in the clouds, which we call upwelling and downwelling, get all mixed up. A whirlwind in the soup. Our clever scientists also noticed something special near Jupiter's equator. They discovered a concentrated spot of magnetism called the Great Blue Spot. And guess what? This spot is slowing down, like it's taking a break from its usual fast movement. This suggests that a new type of wavy motion, a new dance, is about to begin. So, to sum it all up, the scientists have come up with a cool idea. These wavy magnetic movements, the torsional oscillations, disrupt the slow currents inside Jupiter, messing up the cloud patterns and causing wild weather. And when the scientists calculated the time it takes for these wave-like motions to happen, they discovered that they match the same time periods when the stripes on Jupiter change. So, in simple terms, the scientists think that these wave-like movements in Jupiter's magnetic field are causing the changes in the stripes on the planet. Pieces of a puzzle are coming together. Scientists are still trying to fully understand why this happens, but it's an exciting step forward in unraveling the mysteries of our vast universe. But there are still some mysteries left to solve. To find more answers, scientists need to keep watching Jupiter closely in the future. By observing how the clouds change, they can check if their theory is correct or if it needs some adjustments. From its massive storms to its colorful belts, Jupiter never fails to amaze us with its cosmic wonders. It may not have ignited as a star, but it shines brightly as a gas giant, captivating us with its size and beauty. So keep your curiosity alive and always reach for the stars.
Hey, wake up! Quick, listen to that. It's a 5-second FM signal coming from one of Jupiter's moons. You fumble for your phone and inform your colleagues. They freak out over the news and rush to the lab. You've been a scientist working with the Juno probe, exploring Jupiter for years. But this is the first time you've witnessed something so unusual. Ganymede is Jupiter's largest moon and the biggest moon in our solar system. If this space body didn't orbit around Jupiter, it would be classified as a planet. It's even bigger than Mercury and Pluto. What makes this moon stand out among others is the fact that it has its own magnetic field. The moon was born around 4.5 billion years ago. It means it's as old as Jupiter itself. This planet-sized space body takes 7 Earth days to orbit its planet. Everyone gathers at the laboratory, impatiently waiting for you to play the recording of the signal coming from space. Your colleagues get their game on, trying to figure out what the source of this mysterious sound is. Around 40% of Ganymede's surface is dark, with craters scattered around, and 60% is light-colored. There are formations that were probably caused by tectonic activity or the release of water from under the surface. Scientists managed to discover a thin layer of oxygen trapped in the moon's atmosphere. The temperatures there are super low, between -170 to -200 degrees Fahrenheit. There isn't much information about how the moon behaves or what chemical elements it hides inside. Some of your colleagues try to create the same conditions that existed when the sound was transmitted. For hours, they sit there waiting, but nothing. Maybe it was a fluke. You get to the control system and activate the Juno spacecraft. The main point of this mission is to observe Jupiter's gravity, magnetic fields, the atmosphere, and the planet's evolution. By the way, there's also some evidence that Jupiter's largest moon is evolving too. Since it has a magnetic field surrounding it, auroras pop up all the time. Those are glowing gas circling the moon's north and south poles. If life existed in such a place, it would probably be at the bottom of Ganymede's extremely salty ocean. For a long time, scientists thought that the sun was a crucial component to kickstart life. But now we know that there are organisms dwelling deep at the bottom of the oceans. Those are doing just fine without sunlight. The oceans of our planet are teeming with some of the most bizarre creatures of all shapes and sizes. Sea lilies live some 10,000 feet underwater. They got their name because they look like flowers, except they're not plants, but animals. Don't be fooled by their stems and leaves. Those are body parts equipped with nerve endings to detect food around them. Goblin sharks are probably some of the most weird-looking sharks that live at the bottom of the ocean. They can grow up to 12 feet long and have a very unusual snout. Now, take a look at the anglerfish. It has a bioluminescent blob on its head to attract prey and navigate its way around the dark ocean floor. It's a natural flashlight that never needs new batteries. It's only the females that have these flashlights, though. The blobfish is another bizarre animal living down there. It lives in the Atlantic, Pacific, and Indian Oceans, 9,000 feet under the surface. Anyway, even though you asked everyone to keep the news confidential, it somehow leaks to the media and becomes a new trending topic. You get a call from a news agency. They say they want to interview you about this breakthrough that may prove life exists in outer space. The next day, you head down to the news station to talk about your discovery. You have a whole live studio audience watching your every move as you reach out to grab your glass of water. The crew scurries around doing some last-minute checkups before you're live on air. The makeup artist does some final brush-ups. The sound engineer asks you to test your mic once more. Several of the producers are sitting in the front seats. Bright lights are flooding the studio. The countdown begins. 3, 2, 1, and you're introduced, and the host asks you to explain what it was that you heard. You tell them about the Juno space probe orbiting Jupiter. After a couple of questions, the host finally brings up the most dreaded one. Might the mysterious sound be coming from another civilization? Everyone leans in, waiting for you to answer. You freeze, not knowing what to say. Even though the crushing pressure at the bottom of the ocean is 1,000 times stronger than at sea level, life still exists there. Algae, which is considered a delicacy in the ocean world, is off-menu for deep-sea creatures due to a lack of sunlight. Many of these bottom dwellers have to munch on leftovers instead. Those sink down there from the upper layers of the ocean. The freezing temperatures and the intense pressure have altered the cells of these creatures. This has made them more resilient than the average fish. Bacteria were developing their own ways of surviving. Studies show that they feed on certain gases and chemicals, like sulfur and carbon dioxide. Methane and hydrogen are released when tectonic plates move against each other, and some of these bacteria feast upon those gases too. Tardigrades, also known as water bears, are microscopic critters that can live and thrive in extreme conditions. You can find them in volcanoes, frozen glaciers, and even in the empty void of space, which means that some life forms might actually exist on Ganymede. You explain this to your audience. Then you mention that you don't have enough information to determine if it was another civilization or a natural phenomenon that produced the sound. This doesn't mean that the bottom of Ganymede's freezing oceans isn't teeming with its own bizarre and weird creatures. There might be some legendary beasts like the Kraken or Leviathan there, or weird glowing fish with 2 heads, a fish with tentacles and a large fin, giant crabs. The bacteria there might be as varied as our own. The plants, if they exist there, have to be strong enough to survive the sub-zero temperatures. The animals on Jupiter's largest moon could be as big as our blue whales or as tiny as plankton. After the interview, you head back to the lab to examine the records once more. On your way home, you see posters of yourself with captions like, "Are we not alone?" Hey, you've become a celebrity. Many people take pictures of you. You've been booked by other agencies for more interviews. Some science magazines even want to put you on the front cover as the Person of the Year. Every time you come to work, you wait for the sound to appear again. But nothing. You send a signal from the Juno probe, trying to make some sort of contact with whatever produced the sound. Nothing. That night, you pass out on your desk once more. Eureka moment wakes you up in the middle of the night. There might be something you've missed. You run the numbers again and realize that the answer was in front of you this whole time. It wasn't another civilization that produced this sound. The source was electrons. Every planet produces its own sound. It's created when charged particles from the solar wind and the planet's magnetosphere interact with one another. That's what happened on Ganymede. The electrons in its magnetic field, where the probe picked up the signal, were acting stranger than usual, and this amplified some irregular frequencies. You're embarrassed and spend the rest of your night making phone calls, telling your team the news. The agency that interviewed you releases a statement. They explain that other civilizations aren't trying to contact us. You sit back at your desk, waiting for the next big thing to happen. Europa is another of Jupiter's moons that may host life. It's made up of an iron core, a mantle, and a salty ocean, twice the volume of all the oceans on Earth. And just like Ganymede, the ocean lies under a water ice crust. Scientists claim that there might even be active volcanoes there, and some resilient bacteria may live there. With enough water, certain chemicals, and a source of energy, Europa could produce life. But it's unlikely that we'll find anything but tiny microbes.
Sand is everywhere. In your eyes and mouth, in your hair, under your t-shirt, and in your shoes. You can hardly stand. The wind is so strong, it's knocking you down. Suddenly, an especially powerful gust sends you to the ground. You crawl toward the back door. It takes you a lot of effort just to pry it open. Once inside, you get to your feet and sneak a peek outside. Just clouds of dust and a deafening roar. Okay, it's time to call for help. It started a month ago. One day, you went out to the garden behind your house. It was a windy day. You even spotted a tiny tornado under your apple tree. It hardly reached your knee, lazily swirling around tree leaves and dust. You tried to make it disappear by poking it with your foot. But even after several attempts, the mini whirlwind just didn't want to break apart. You shrugged and went back home. The next day, the tornado was still there, and had it grown? Interestingly, instead of growing taller, it got wider. At that moment, it started munching on your flowering shrubs. You got curious and decided to keep track of this unusual phenomenon. You measured it every day and carefully wrote down all the information in a special notebook. Maybe later I'll write an article or even publish a book about my storm, you thought. One day, you got out of the house to find your favorite apple tree broken. You couldn't figure out how it happened. The storm still looked harmless and too weak to damage a rather large tree. But after this accident, you started asking yourself if not calling for help was the wrong thing to do. Apparently, it was, because just a month later, your mini-storm has suddenly grown to twice its original size. It's unsafe to go outside now. It seems as if your house is in the middle of a real tornado. You can't see the sky behind a wall of dust and debris. Your garden is ruined, trees broken, bushes and shrubs pulled out of the ground and sent flying somewhere far away. You hear your doorbell ring. A group of scientists you invited has come to the rescue. You show them the garden with your personal natural disaster and enjoy their stunned silence. But after a couple of seconds of initial shock, they spring into action. Ignoring the howling wind, they start carrying inside different equipment. It looks very complicated. Your kitchen turns into the researchers' laboratory. You get informed that your house will be temporarily used by the scientists. You take your things to the smallest bedroom and watch the professionals work. Your kitchen is filled with beeping gadgets and devices covered in flickering lights. People in protective suits and lab coats scurry around. Surprisingly, they don't bump into each other. Neither do they create traffic jams. You bring the notes you've been taking and hand them to an elderly man in a white lab coat. He thanks you as if you've just given him the gift of his dreams. The next several days pass in a flurry of activity. The storm in your garden is growing. The scientists seem to get gloomier every time you see them. It's around 2 a.m. when something wakes you up. You blink your eyes open and realize the house is shaking. Your homegrown tornado must have gotten so big, it's reached the house. In the morning, several scientists pull you aside to tell you the unpleasant news. You have to move out. The storm is indeed growing. Soon, it'll wipe your house off the face of the earth. Nothing can be done. You're gaping at the people telling you to get out of your house. Where will you go? They tell you they're building an additional research lab not far from the place. It's important to be able to observe the storm in real time. Anyway, there's a spare room with everything you may need in that facility. Why don't you stay there for a while? It would also be convenient for the scientists. They may need you to answer the questions that appear during the process. You agree because you don't have any other choice. The researchers help you transport your stuff to your new accommodation. You walk around your house, saying goodbye to your favorite coffee table, your sofa, and your cozy bed. The scientists tell you that there's no time to move your furniture to another place. The next day, you wake up to the news that your home is gone. The storm gulped it down at around 4 a.m. Over the next few weeks, the grown-up whirlwind has swallowed 2 houses of your neighbors, the nearby forest, several abandoned cars, and a small flower store. It's now so big, it's coming close to a large lake several miles away from the town. People get evacuated. The authorities have announced a state of emergency. One day, you notice that scientists are talking in hushed voices. They look even more worried than usual. You corner one of them and try to find out the truth. Soon the scientist spills it. The researchers have got some evidence that confirms their worst fears. According to all their estimates, the storm that once started as a tiny tornado in your garden is going to grow into another great red spot. Only on Earth. Crimson-colored clouds are spinning counterclockwise at an incredible speed. Beneath them, you can see vibrant hues of the largest planet in the solar system, the gas giant Jupiter. Those clouds are called the Great Red Spot. It's a colossal storm raging in the atmosphere of Jupiter. If you found yourself at the storm's center, the winds would be rather calm there. But on the edges, the storm's speed can reach 425 miles per hour. That's twice the speed of the fastest and most severe hurricanes on Earth. Over the decades, the size of the red spot has been changing. Right now, it's 1.3 times as wide as our planet. The storm's roots go as deep as 200 miles into the planet's atmosphere. The average tropical cyclone on Earth usually stretches for no more than 9 miles from the bottom of the storm to its top. The unique phenomenon on Jupiter has existed for so long because the planet doesn't have a solid surface. It consists of layers of clouds made up of vapor, water ice, and ammonia. Underneath, there might be an ocean of liquid hydrogen. Our planet is solid, and hurricanes slow down and break apart once they go low enough to touch the surface. But the Great Red Spot has nowhere to make landfall. That's why it keeps raging. The scientist also tells you the most bizarre and alarming thing about the storm in your garden. Instead of growing weak and disappearing many weeks ago, it's not only still going, but it's also getting bigger and more powerful. Even the most experienced specialists can't explain this phenomenon. After analyzing it for days on end, they've come to the conclusion that it shouldn't have appeared on Earth. It's against the laws of nature. Interestingly, the storm's composition is a bit similar to that of the Great Red Spot. You're impressed, but still can't get why the researchers look so worried. It turns out that your once mini-storm is likely to grow as large as that on Jupiter. But since Earth is way smaller than the colossal red spot, it's likely to swallow our planet whole. It'll grow and grow, wiping out towns and cities, forests and highways. At the same time, it'll become more powerful. People will have to leave their homes and get evacuated to relatively safe areas, until there are no more safe areas left. This process will take years, but it'll still be too fast for people to prepare. There will be 2 ways to deal with this global problem. One of them is to colonize the moon or another planet, for example, Mars. But it's an incredibly long process, and the storm will conquer the entire planet before the first spacecraft with people leaves Earth. Or scientists may try to stop the hurricane. There's a technology called the sunglasses effect. Billions of tons of dense gas get pumped into the atmosphere. This gas absorbs sunlight and cools down ocean water, which is the engine of any hurricane. The researchers aren't sure if this method will work with your storm. It formed not over the ocean, but in your garden.
It was January 7th in 1610 when Italian astronomer Galileo Galilei made an astonishing discovery using his homemade telescope. 4 moons orbiting the planet Jupiter. By the way, these days you can make your own version of his telescope using cardboard tubes, lenses, and some superglue. The main point of this DIY telescope is to place 2 lenses at the correct distance from each other. You'll need 2 lenses. One lens should be concave, the other one convex. So one lens is curved out and the other one is curved in. Galileo's initial telescope was able to magnify objects approximately 8 times. He continued to improve it until it reached about 20 times the magnifying power. But let's get back to the main story, shall we? When he first looked at those 4 moons of Jupiter, he believed he was simply looking at a bunch of stars. But he soon noticed that these space objects seemed to be moving in a regular pattern. It took him a couple of weeks to figure out that what he was looking at were not stars, but moons circling Jupiter. Galileo initially named those moons 1, 2, 3, and 4. But let's face it, those weren't the most creative names. As more moons in our galaxy were discovered later, the numerical system for naming them became confusing and impractical, so it lasted for just a few centuries. So, these days, those 4 satellites, Jupiter's largest, are named Io, Europa, Ganymede, and Callisto. They're collectively known as the Galilean moons to honor the man who first noticed them. Galileo's discovery was crucial for our later understanding of astronomy. It was initially believed that other objects revolved around the Earth since it was seen as the center of the universe. We now know that there are hundreds of moons in our solar system. However, large moons, like those discovered by Galileo Galilei, are not so commonly stumbled upon. A moon is considered large when it's the size of our planet or bigger. Ganymede, for instance, is bigger than Mercury. We basically call Ganymede a moon just because it orbits Jupiter. Otherwise, it has all the other characteristics of a planet. It's no surprise that Jupiter has the biggest moons in the area. It beats all the other planets in our solar system in both size and mass. So no wonder it pulled in a lot of other objects towards it. Jupiter is believed to have in total almost 80 moons, with only 53 of them being given official names until today. The first of those Jupiterian moons to be discovered by Galileo was Io. What sets it apart is the fact that it has a lot of volcanoes. Io is the only space object to have active volcanoes in our solar system, apart from Earth. It's also nicknamed the Moon of Fire and Ice because of its sulfur dioxide snowfields. Io's outer layer is splotchy, featuring multiple colors like orange, black, yellow, white, and red. That's probably the reason why NASA described it as a giant pizza covered with melted cheese and splotches of tomato and ripe olives. Because of that sulfur though, Io doesn't smell that appetizing, something similar to a rotten egg. There are more than 100 mountains on the surface of this moon. They are a lot larger than those we see on Earth, some being bigger than Mount Everest. On average, these mountains are 4 miles tall and 98 miles long. Because of those active volcanoes and the intense radiation on Io, there's little chance that life as we know it could exist here. But hey, who's to say it can't have life the way we don't know it? Next on the list of Galilean moons is Europa, the smallest of the 4. It's comparable in size to the Moon. Europa has an entirely icy surface, with just a bunch of craters scattered here and there. Because of that outer layer, Europa is very reflective, making it one of the brightest moons out there. As for its age, scientists believe its surface to be somewhere between 20 to 180 million years old. Europa is about 4.5 billion years old. What lies beneath that icy surface is impressive. It may even hold the secret to life outside Earth. Ice forms here in 2 ways. The first is through congelation. A rather self-explanatory process. Ice just grows as the surrounding environment gets colder and colder. The other method, though, is a lot more fascinating. A layer of supercooled water found under the ice shell reacts when agitated. It then generates these crystals that make it look like it's snowing in reverse, floating upwards to the ice sheet they sit under. You can recreate this environment yourself at home. Take a bottle of purified water and place it into the freezer. If you don't have purified water anywhere near, just boil some water a couple of times to get rid of as many impurities as possible. Since there won't be any particles inside, once in the freezer, it won't turn solid. But if you take the bottle out of the freezer and give it a shake, the impact will make the water rapidly crystallize, transforming it into a slush-like consistency. There may be water on Europa, but there's little evidence so far that life exists on this moon. However, it's one of the highest candidates in the solar system for potential habitability. Some sort of life forms could adapt to live there in its under-ice ocean. That environment is most likely similar to what we can find in our planet's hydrothermal vents hidden deep within our oceans. The amount of oxygen in Europa's atmosphere is very little, but in 2013, NASA gave away some cool evidence. This yet again supports the theory that there's potential for life on this moon. It seems that Europa might be venting water into space. If this is confirmed by future observations, it could also mean that Europa is geologically active. It could also come in handy if we'd managed to study water sources one day. The largest of those Galilean moons is Ganymede. It's also the biggest moon in our solar system altogether. It's a low-density space object similar to Mercury in size, but having only half of its mass. However, Ganymede is the only moon out there to feature its own magnetic field. It's quite small though, and we can barely notice it from Earth since it's overshadowed by Jupiter's much more powerful magnetic field. Another cool aspect of Ganymede is that its atmosphere contains oxygen. Don't get too excited, it's not nearly enough to support any life forms living there. Back in December 2021, a 50-second audio clip was released, which was previously recorded by NASA's probe on its Ganymede flyby. For the inexperienced, the sounds were more similar to those of an old dial-up internet connection, but because of its quirky tunes, Ganymede was soon nicknamed Jupiter's singing moon. Finishing up the list of Galilean moons is Callisto, or the most heavily cratered object in our solar system. What's interesting about this moon is that its landscape has barely changed since it formed, and scientists are still debating why this is happening. Most other space objects go through loads of changes throughout their lifetimes because of events such as collisions with other objects, changes in orientation or speed, or chemical reactions happening on their surface. Callisto is also about the size of the planet Mercury, but it has a lower density. Jupiter's magnetic field has a lesser impact here, since Callisto is the furthest from the giant planet. Its surface is estimated to be a staggering 4 billion years old. As opposed to Io, Callisto is not geologically active, but scientists believe there might be an ocean hiding underneath the moon's surface, which may potentially harbor life. The fact that it's less impacted by Jupiter's magnetic field means that it features low levels of radiation. Given this suitable environment, we may one day end up setting a human base for future explorations here.
Ah, well-deserved vacay, finally. This time you're off to see something new. It's an ocean on one of the Uranus's moons. Alright, just kidding. This destination is not a vacation spot yet. But yeah, there are definitely some impressive oceans out there. Hey, don't say you thought oceans can only be found on Earth. But before diving into Uranus Moon's oceans, let's talk about Uranus itself first. The 7th planet from the Sun, and the coolest cat in the solar system. It's got 27 moons, and 4 of them might technically have oceans. That's more than most people have, friends. All these moons are like Uranus's mini-me's. They tilt at the same crazy angle as their parent planet, 98 degrees to be exact. And Uranus is so unique that it orbits the Sun on its side. That means its equator is almost at a right angle to its orbit. Talk about rebellious. But why is Uranus like this? Well, some astronomers reckon it's because it got knocked on its side by a massive collision with another planet. And that impact might have actually created Uranus's moons. Fun fact, those moons have pretty particular names. Instead of mythical figures, most of them are named after Shakespearean characters. I mean, who needs Zeus when you've got Juliet and Desdemona? Discovering these moons isn't easy. They're super dark and located billions of miles away from the Sun. It's like trying to find a needle in a haystack, except the needle is smaller than your pinky finger. These 27 satellites are divided into 3 groups. 13 inner moons, 5 major moons, and 9 irregular moons. The irregular ones are rebels with retrograde orbits, while the others are prograde and go with the flow of Uranus. The big boys are Miranda, Ariel, Umbriel, Titania, and Oberon, and they're all in Uranus's equatorial plane and are big enough to be round. They've got craters and canyons and cliffs. Oh my. These moons also formed from a giant impact that tilted Uranus on its axis. That's why they're all tilted too. And because of that tilt, they have crazy seasonal cycles just like Uranus itself. But we haven't found all of Uranus's moons yet. The little irregular ones are sneaky and hard to detect, so who knows how many more there could be. But let's talk about the really cool stuff, what these moons are made of. We're not entirely sure, but we think they're made of rock and ice. Miranda is the most icy one, while the inner moons are probably just dusty, and the ones beyond Oberon's orbit, they're likely captured asteroids that could be rocky, or icy, or who knows what. But here's what really sets Uranus's moons apart. They're all tilted together with Uranus. That's wild. Exploring these moons could teach us so much about how ocean worlds form and stay active. Titania is the biggest moon of Uranus, but it's still less than half the size of Earth's moon with a diameter of about 1,000 miles. It's also the 8th heaviest moon in the whole solar system. They named it after the fairy queen in A Midsummer Night's Dream. Titania's color is gray, and it has some shiny patches that scientists think are frost. It's made up of a mix of ice and rock, just like all the other moons close to Uranus. Oberon is the next biggest moon of Uranus, named after the fairy king in Shakespeare's play. It's almost the same size as Titania, and also has a half-ice/half rock composition. But Oberon's surface is way more cratered than the other Uranian moons. Umbriel and Ariel are the 3rd and 4th largest moons of Uranus, with diameters of 726 miles and 718 miles respectively. Umbriel is named after a bad spirit in an old poem, and it's the darkest of all Uranus's big moons. It only reflects 16% of the light that hits it. Scientists don't know why it's so dark, but they think a bright ring around a crater might be caused by frost deposits. Ariel is the brightest of all Uranus's big moons, and it reflects over a third of the light that hits it. It's named after characters in both Pope's poem and Shakespeare's play. Ariel looks like the youngest moon because it only has a few small craters from recent collisions. Miranda is the smallest of all these big moons with a diameter of about 292 miles. NASA says it looks like it's made up of parts from different bodies, like a Frankenstein's monster. Miranda has 3 big features called coronae that are unique to it. They're lightly cratered with ridges and valleys, and they're separated from older and more heavily cratered parts of Miranda by sharp boundaries. It also has giant canyons that are up to 12 times deeper than the Grand Canyon. Scientists don't know why Miranda has such different features, but one theory is that it got smashed apart by a huge collision and then put back together all wonky. All these big Uranian moons are stuck facing Uranus all the time, just like Earth's moon. Uranus has got some seriously dope features, but the ring system is where it's at. And get this, the ice giant's moons actually have a hand in shaping those rings. Uranus has 13 inner moons and 13 faint rings, and they're all connected like one big cosmic family. Cordelia and Ophelia are like the guardians of the outermost ring, Epsilon. These 2 shepherd moons keep all the particles together, with Cordelia being the closest to Uranus's surface. But here's the kicker. There are at least 8 other tiny satellites hanging around in that area, making things super crowded. NASA is still scratching their heads trying to figure out how they don't all crash into each other. The inner moons are half ice and half rock, but we don't know much about the outer ones. NASA thinks they might just be asteroids that got caught up in Uranus's gravitational pull. Either way, Uranus and its moon squad are definitely out of this world. Apparently, Uranus's moons might have salty oceans hiding under their frozen surfaces, and the farthest ones from Uranus, Titania, and Oberon could have oceans that are 30 miles deep. That's deeper than the Mariana Trench, 7 miles. But even Ariel and Umbriel might have oceans around 19 miles deep. NASA used some fancy computer modeling and revisited data from their Voyager 2 spacecraft, launched way back in 1977, to figure out the makeup and structure of these moons. They found that Titania is huge enough to keep its internal heat and prevent its ocean from freezing. But get this, the other moons might have a chance at having warm oceans too. The researchers discovered potential sources of heat in the moon's rocky mantles that could release hot liquid and keep the oceans warm. And guess what? The oceans might even be warm enough to theoretically support life. The study also found that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. Now you might be thinking, how can these icy moons have liquid water? Well, turns out their internal heat and some chemicals could make it happen. For example, a study revealed that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as an antifreeze, and salts in the water could also help maintain the ocean's temperature. And if these moons really do have oceans, that means there could be other ocean worlds in our solar system and beyond. But don't get too excited. These oceans are pretty salty. About 150 grams of salt for every liter of water. That may not be saltier than Utah's Great Salt Lake, but still. As for Uranus's fifth biggest moon, Miranda, welp, it might have had an ocean at some point, but it probably froze over pretty quickly. Poor little guy. Anyway, NASA is thinking about sending a mission to Uranus to learn more about these icy giants and their moons. They're calling it the Uranus Orbiter and Probe, UOP. Sounds like a party to me. So yeah, technically there might be not 4 but even 5 oceans, but there's still much to learn and explore.
Jupiter, the fastest spinning planet in our solar system, with a day lasting only 10 hours. The biggest planet in our solar system, a gas giant more than 300 times as massive as Earth. It has rings of dust and colorful bands stretching across its surface, which are actually gases. And then there's the Great Red Spot, iconic raging storm, huge hurricane, 2 to 3 times as wide as the whole Earth. It's also insanely deep and goes around 300 miles into Jupiter's atmosphere. That's 40 times as deep as the Mariana Trench, the deepest oceanic spot on Earth. Way more extensive than scientists expected. Researchers have speculated about the Great Red Spot for hundreds of years already. This storm is circling Jupiter in its southern hemisphere. At the center of this giant spinning storm, the winds are relatively calm. On the edges, wind speeds go up to 425 miles per hour. That's twice as faster than the strongest hurricanes on our planet, 175 miles per hour. When there's a hurricane on Earth, it goes wild at first, but eventually starts to slow down. It finally breaks apart when it reaches solid land. Jupiter has a sky that's 44 miles deep. There are layers of clouds, and beneath them, scientists believe, lies an ocean of liquid hydrogen. The planet's core is supposed to be right under that ocean, but we're still not sure what exactly it's made of. As far as we know, Jupiter is a gas world, so there's no solid ground that would stop the storm. That's why the spot continues to rage on and on. Scientists realize the storm is constantly changing its size. Compared to data from 1850, it's shrinking right now. The Great Red Spot used to be 3 times the size of Earth. It's been a long time since it last got bigger. As it's shrinking, the storm gets taller and changes color into an intense orange, possibly because of the chemical reactions. New matter raises from the bottom of the storm. The red Great Spot could continue shrinking and eventually disappear in the next 10 to 20 years. But there could be another similar storm emerging somewhere else on Jupiter, if the red Great Spot ever ends. This storm might seem very deep, but it's still shallower than the giant jets of wind that rage around it and power the storm even more. Jupiter's bands of wind go to depths of 2,000 miles below its cloud tops. Jupiter is generally known for having crazy windy conditions in the upper and lower parts of the atmosphere. The middle part is called the stratosphere, and we didn't know what was going on there. Scientists usually measure wind power by watching clouds, and there are no clouds in the stratosphere. But when a comet, Shoemaker-Levy 9, collided with Jupiter in 1994, scientists got a chance to study cometary structure and composition and its effects on Jupiter's atmosphere. They discovered insanely strong winds in the stratosphere with speeds of 900 miles per hour. Jupiter isn't the only planet in our solar system with crazy weather. Mars has the biggest dust storms amongst all 8 planets. When such a storm is raging, it seems like it creates a blanket over the entire planet that lasts for months. One theory that tries to explain why dust storms are so big on Mars says airborne particles of dust absorb sunlight and warm the planet's atmosphere. This creates warm pockets of air. They start flowing toward colder areas, which then generates winds. These winds lift dust off the ground, which heats the atmosphere, makes winds stronger, and kicks up more dust. Mars generally has a very thin atmosphere. It mostly consists of carbon dioxide, and the volume of gases in the Martian atmosphere is less than 1% of that of our planet. But Mars used to be much wetter and warmer than it is today. That means its atmosphere was much thicker. A long time ago, it created a strong greenhouse effect and trapped the sunlight. Mars used to have a pretty strong magnetic field. Just like on Earth, the magnetic field on Mars was created by currents of molten metals in its core. But unlike our planet, the inside of Mars cooled enough to switch off the magnetic field. Without it, Mars wasn't protected from the solar wind. That's a powerful stream of particles flowing from our sun. It took only a couple of 100 million years, which is not much in space terms, for the solar wind to strip away most of the atmosphere on Mars. It went quickly because the sun used to rotate much faster at its earlier stages, so the solar wind was more powerful and energetic. And that's how Mars turned from a planet with a warm, wet climate into the cold, dry place it is today. Mars also has some interesting glaciers. They've been on its surface for hundreds of millions of years and can tell us secrets of the planet's past. For instance, that's how we found out Mars went through 6 to 20 separate ice ages during the past 300 to 800 million years. Satellites took images of 60,000 rocks of different sizes. They were distributed across the entire planet at random. If Mars had a single, long ice age, we'd find a progression of bigger to smaller rocks because they erode as time goes by. But the rocks were spread in clear bands of debris across the surface of these glaciers. Each band marked a different flow of ice, which means each of them formed during a different ice age. These glaciers are like time capsules because they could have all kinds of gases, rocks, or even microbes trapped inside. That means they could help us understand the changes in climate on Mars and tell us if there used to be any form of life on the planet. And the best thing, we don't need to drill deep down below the crust to find that out. Everything's on the surface. If you could go back in time, let's say 4 billion years, and visit the red planet, you'd probably see chaotic scenes of flooding. Scientists believe that megaflood happened because of a huge meteoritic impact. Because of the heat from that impact, ice on the planet's surface started melting. This flood carved out big ripples and waves in the sedimentary rock. Some wave-shaped features are over 30 feet high and spaced out 450 feet apart. Saturn also has its own unique weather conditions. Lightning bolts there can be 10,000 times more powerful than the ones we have on Earth. NASA's Cassini spacecraft was orbiting Saturn from 2004 to 2017. It captured lightning so strong and intense, we could see it even during the daytime. Cassini also recorded the sounds of those intense storms discharged into the planet's atmosphere. From time to time, Saturn has giant storms that go over 190,000 miles across the surface. They encircle nearly the entire planet. On Saturn's North Pole, there's a massive hexagon of clouds. It's a vortex of a pretty unusual shape that circulates hundreds of miles above the clouds and extends deep into the planet. But Saturn has its peaceful side too. Along with Jupiter, Uranus, and Neptune, it has its own beautiful auroras from time to time. All 4 planets have an atmosphere dominated by hydrogen. That's why you can only see these auroras in ultraviolet wavelengths. These northern lights are especially bright at dusk and right before midnight. Venus has a giant storm swirling in the atmosphere at its south pole. The vortex is as big as the entirety of Europe, and it's probably been there for a very long time. The atmosphere on Venus moves 60 times faster than the planet rotates. Venus is the hottest planet in our solar system. Even the rain there offers no relief, since it's sulfuric acid falling from clouds and evaporating before it even gets to the ground. The sun also has its own angry outbursts in the shape of powerful solar storms. These storms bring strong radiation and dust particles that can cause serious damage to satellites that track the sun's activity to let us know if something goes wrong. Every now and then, a crazy solar storm can catch us off guard. About 160 years ago, a strong solar flare caused severe issues in global telegraph communications. About 30 years ago, a solar flare left 6 million people without electricity for 9 hours. One theory says strong solar activity could have caused the sinking of the Titanic. It happened on the same night as a fascinating northern lights show. Some people believe a solar storm behind it had possibly disrupted the ship's communication systems and navigation, leading to one of the greatest unsolved mysteries ever.
Jupiter has 79 known moons. and the 4 biggest of them that are particularly interesting are Galilean moons. They were named after Galileo Galilei. He discovered them in the 17th century. They have something in common, but at the same time are all very different. Europa is the smallest of the Galilean moons with a diameter of 1,860 miles. It orbits Jupiter every 3.5 days. The first images we got from there were taken in the 1970s. Its surface mostly consists of water ice. Europa has long fractures, often around a mile wide, that can extend for thousands of miles across its surface. They were probably formed as the crust pulled apart from tidal forces on the mysterious ocean beneath the surface. In 2012, scientists discovered water vapor plumes erupting close to its south pole, rising up to 125 miles. These plumes can help us find what's inside Europa without having to land there. Scientists think there could be a magnificent ocean hidden 10 to 15 miles beneath the solid surface. That ocean could be 40 to 100 miles deep. Even though it's just 1/4 of Earth's diameter, it contains twice as much water as all of our oceans together. This ocean is a potential environment for some forms of life. Scientists believe the entire ice crust is floating on that ocean. It probably makes a full rotation around Europa once every 12,000 years. In the image the Galileo spacecraft took, you can see small dark brown spots. They're 6 miles across and formed as the hot, less dense material was getting to the surface. It either pushed the crust or broke through it altogether. The surface of Europa consists of so-called chaos terrains. They're rough areas surrounded by a smoother surface. Its equator could be covered in ice spikes called penitentes that can go up to 50 feet high. We have them on Earth too, especially in dry areas at high altitudes. But none of them are as big as those on Europa. Our moon has over 5,000 big craters with a diameter of more than 15 miles. Europa's surface lacks impact craters and doesn't look like it's more than 50 million years old. This means the surface of Europa is changing and reforming all the time. This moon is icy and is one of the smoothest of any solid space objects in our solar system. Because of it, it's 5 times brighter than our moon. Europa is under a constant blast of radiation coming from Jupiter. It's so strong, we wouldn't last even a day there. Europa is 5 times further away from the center of our solar system than Earth. That means it barely gets any heat coming from the sun, so it can remain frozen since the average temperature is negative 250 degrees Fahrenheit at the equator and around negative 360 degrees Fahrenheit at the poles. About 40 years ago, the Voyager 1 spacecraft came close to the rocky moon Io and discovered that it's a volcanic champion of our solar system. Io is Jupiter's 5th innermost moon, 4.5 billion years old, nearly the same age as Jupiter itself. It's similar in size to our moon, and even has a similar density and amount of gravity. Many moons in our solar system consist of silicates and water ice, but Io is made of iron and silicate rock. You'd be able to see some beautiful auroras on Io. As this moon rotates around Jupiter, auroras change brightness all the time, but they're always there. Io is relatively close to Jupiter, almost 260,000 miles above its cloud tops. If you could come to Io and take a look at Jupiter from there, it would appear almost 40 times bigger in the sky than our moon. Stargazing there would be amazing. Io needs 42.5 hours to orbit Jupiter. Our moon needs almost a month. At some points, Io's tidal bulge can go up to 330 feet. It's similar to what we have on Earth. The gravity of our moon causes ocean tides. Io doesn't have an ocean, but the ground itself moves and goes up and down. It's like an elevator taking you to the bottom and then the top of a building with 30 stories. The gravity of Jupiter and its other big moons affect Io, so the solid ground tides on its surface are over 5 times as high as the highest ocean tides on our planet. All this makes Io so hot on the inside that some of the inner materials melt. boil, and try to escape in any way possible. Eventually, it creates a hole in the ground, which then turns into a volcano. Io is the most active body in our solar system when it comes to volcanoes. Io has more than 400 of those, with 150 of them erupting all the time. Some of them shoot their hot gas plumes 200 miles into space. It would be difficult to walk there because we're talking about a pretty intense world of floodplains of liquid rock, huge lava flows, multiple lava lakes, and giant collapsing mountains. Ganymede, the largest moon in the solar system we know of, also has the biggest water ocean. It's 26% greater than Mercury when it comes to volume, but it's less dense. This giant moon has a thick crust of water ice 90 miles deep. There might be a huge ocean of liquid water underneath. It extends 60 miles deep, which is about 10 times deeper than the deepest point in the Earth's ocean. The Voyager spacecraft also detected polar caps made of water frost there. Ganymede is half rock, half water, including tiny amounts of metals and ice. Its atmosphere is very thin and doesn't contain oxygen. This ocean most likely doesn't contain life. The Earth is a great example of how certain microbes and creatures can survive deep down without sunlight. But the ocean of Ganymede is so deep and the pressure is so strong that the water at the bottom is probably compressed back into ice. Certain forms of life in the deepest areas of our ocean survive thanks to geothermal vents that eject minerals. Since there's likely thick ice between the ocean and the core, this isn't the case with Ganymede. But the ocean there is salty, with multiple layers divided by icy sheets. If there's any chance of life, it could be in the part where the rocky core is in contact with the most internal icy layer. Beneath all that water and ice, Ganymede is the only moon in the entire solar system with a magnetic field. It's possible because this moon has a liquid core. Ganymede circles Jupiter approximately once every 7 days. Its orbit is so eccentric that at some points, it's pretty close to Jupiter. Ganymede, Io, and Europa have gravitational forces that affect each other. In the time Ganymede orbits Jupiter once, Europa makes 2 orbits, and Io makes a full circle 4 times. 1/3 of Ganymede's surface contains big dark regions, while the other 2/3 are lighter. Dark areas are older and contain more craters. Lighter areas have long ridges and grooves, about 2,300 feet high and thousands of miles long. Callisto, the third biggest moon in the solar system, 3,000 miles in diameter, needs 17 Earth days to orbit Jupiter. Its atmosphere is very thin. There are many impact craters, but its ancient crust has basically been the same for more than 4 billion years. When a planet is geologically active, like the Earth, some things can erase most of the evidence from past impacts. Water, volcanoes, tectonic plate movements, human activity, and weather. All this changes the surface. Callisto has experienced none of those. Scientists think this moon used to be an ocean world that eventually froze over. It was hit by meteors from time to time, but mainly remained untouched. And yet, it still has some pretty impressive craters, like Valhalla, the biggest multi-ring crater in our solar system. That's 2,500 miles in diameter. Major craters on Callisto contain more rings than those on other celestial bodies. Whatever hit the moon was big enough to have punctured the thin crust, causing water to spread on the surface. And under this thin crust, there could be either salty ocean or soft ice. The Galileo space probe detected that Jupiter's magnetic field couldn't penetrate through this moon, likely because of a layer at least 6 miles thick. That's why it's hard to explore Callisto. Moons like Europa have vents that eject water from the subsurface oceans. But to explore Callisto and discover more about its past, we'd have to use the old-school way, digging through the crust. If we wanted to explore the outer parts of our solar system, Callisto would be a great spot because Jupiter's radiation doesn't reach it. So we'd be safer there than on some other inner moons.
Hey, ever wanted to taste a salad from space? Well, you might be able to one day. Scientists have taken soil from the moon and successfully grown plants in it. Back in the late 60s and early 70s, it was the first time in our history we set foot on a surface that wasn't Earth. During the several trips to the moon in the Apollo program, astronomers brought back some rocks and soil to study. The researchers named the lunar soil regolith and used the seeds of a particular plant called you can read it here, which is found in Asia, Europe, and parts of Africa. They crossed their fingers, not knowing what would happen. The only thing they did know was that the lunar soil was too poor in nutrients to sustain any plants. So they created a lunar soil stimulant made from volcanic ash to replace the real lunar soil and went to work. Since they needed two separate experiments, they planted the seeds in Earth soil. It was a controlled experiment. They also planted some seeds in the lunar soil as the variable. They were very careful and used a single gram of lunar soil for the experiment. To their surprise, it only took 2 days to see little green leaves and 6 days for them to be properly visible. But sadly, after day 6, the lunar soil plants stopped growing. The soil wasn't enough to provide the needed nutrients for the plant to thrive. The seeds in the soil from Earth, however, grew lavishly. But not all was lost. Even though the lunar plants didn't continue growing, they survived and were harvested 20 days later. Sadly, they still didn't produce a yummy space salad. The scientists then studied the biological form of the plants and found out that the lunar plants were developing under a lot of stress, as if they were growing in a harsh environment, compared to their counterparts in the regular Earth soil. Either way, the study was a huge success. It was the first step in growing food in the soil that wasn't from Earth. NASA planned on a new moon landing in 2024, but due to some complications, it was pushed back to 2026. This will be the first time a person sets foot on the moon since Apollo 17 in 1972. The next moon landing mission will allow us to collect more lunar soil samples to experiment with other crops and see which ones can live longer. Lunar soil in its natural state is far from the quality soil we have on Earth, but we might find a way to reduce the stress plants growing in it have to endure. Perhaps it'll let plants develop in similar conditions they would have in a proper natural setting. There might be other materials on the moon that can help plants grow healthy. The mission will be under the Artemis program. Elon Musk's SpaceX has been commissioned to build the lunar landing vehicle. At first, they will launch a test flight lasting about 3 weeks and then send astronauts to land at the moon's south pole. Because that section is untouched by sunlight, scientists believe there might be water ice craters there that can be used to make rocket fuel. It would lower the cost of future moon expeditions, since fuel wouldn't have to be imported from Earth. Besides potentially growing plants in lunar soil, using water ice from the craters as fuel would be another way of making the moon self-sufficient for space exploration. Now, Mars would be one of the most difficult places to migrate to when you consider how Earth sustains life. But scientists believe that with the right engineering and living conditions, Mars can potentially become our new home. The red planet has a very similar force of gravity to that on Earth, which means that constructing buildings with proper infrastructure wouldn't be much of a problem. Our biological clocks wouldn't be too affected either, since a day on Mars is roughly 40 minutes longer than on Earth. Elon Musk plans on sending out robots to test the conditions on Mars before humans set foot there. These robots will be humanoids, mimicking the way people walk and move. They must be built in a special way to test how the conditions on Mars would affect us physiologically. These robots can also start constructing buildings for people to live and work in. We would have to be tremendously advanced in our agricultural innovations to grow crops in hostile environments. Despite being called the red planet, Mars is actually chilly, so we'd have to build giant dome-like structures to house a human population. They'd need to be self-sufficient enough not to have to rely on Earth's natural resources. These domes would protect us from harsh sandstorms and sub-temperatures. Now, a mission to Mars might not happen in our lifetime, but at the moment, we can take the first steps. Since we've found out that we can use lunar soil to grow something, the next step is to understand more about the process. We won't be living on the moon anytime soon, so we can use the studies of lunar soil to help us solve some problems on Earth. Countries like India are adapting smart farming that uses robots to speed up the process. Some robots are designed for seeding, harvesting, watering, and other tasks. Robotic manufacturers are in high demand now. They produce unique machines like self-automated tractors and aerial vehicles that can hover over fields and water crops. This form of farming will increase productivity and reduce overall costs. It will also help save water by studying the exact volume crops need. A cool, innovative way of farming is vertical farming, which can be done in heavily populated cities. You can practically use any abandoned warehouse or building to do it. It recycles water used at the top of a vertical farm. It drips to lower levels and is then used again. The farmers stack plants in vertical beds for the water to drip easily. They also use both natural and artificial light. These farms are usually soil-free. Instead, plant roots remain in a nutrient-rich solution that is constantly monitored. This method is cost-efficient and supplies plants with the exact amount of nutrients they need. Other vertical farms use ponds with fish living at the bottom. These fish produce waste that is very rich in nutrients. Plants can use it as food. Vertical farms are growing more popular and may soon replace traditional farming. Vertical farming will allow farmers to grow almost 10 times the amount of produce than a plain field, all because they utilize the space above and below. You don't have to worry about little critters on the ground stealing your crops. You should only worry about flying ones. Indoor farming is becoming very popular. Crops growing outdoors always face natural hazards that can damage them. But with indoor farming, we won't have to rely on seasons to grow certain crops. Indoor farms can replicate the conditions of all climates, and we can have any fruit or veggie at any season. There's also genome altering to make every crop the best of the best. It will eliminate any bad seeds, literally. We won't have to waste tons of crops that aren't suitable for consumption. They can have extra nutrients and be healthier. All of these methods are just the first few steps before we begin with space agriculture on planets with hostile environments. Growing plants in space isn't something new. The International Space Station has an array of specialized gardens for growing veggies. Scientists are studying growing crops and plants in zero gravity, which can provide fresh food for astronauts. They use LED lights above plants to accelerate their growth and install proper watering mechanisms. This might be useful for a handful of astronauts at the International Space Station. But what if we were traveling across the galaxy to populate new planets? Well, we'd have to consider a large space dedicated to indoor farming. On the other hand, technology is likely to improve so much by then that we won't even need veggies and fruits in our daily diet. There might be other yummy alternative stuff to munch on. But hey, I'd rather have that space salad, please. Do you have any croutons? Extremely hot and insanely fast. Yeah, that's me. Oh wait, you mean the space thing. Okay, first, they discovered Peg 51, an exoplanet that orbits a star similar to ours. An exoplanet is any planet outside of our solar system that orbits a star that's not the Sun. This planet was completely different from anything we've ever found. Almost the same diameter as Jupiter, but half the gas giant's mass. It took only 4 days for this exoplanet to orbit its star, which seemed impossible. It was definitely too fast for something so massive. And then, scientists started finding something they've named hot Jupiters all over space. Lots of heated gas giants were located only a couple of million miles away from their stars. Sometimes, there were a couple of space bodies orbiting their stars pretty closely, and many were a few times bigger than Earth. Solar systems where they found hot Jupiters are not like ours. We have a neat system with smaller rocky planets on the inside and big gas giants on the outside. And almost all of them peacefully orbit the Sun, following their trajectories. Everything is in order. When a star is at the earliest stage of its formation, it creates a disk of gases, debris, and dust surrounding it. It's called an accretion disk. These gases slowly get pulled into the star because of its gravitational forces, and this leads to some kind of a stellar whirlpool. The outer parts of the disk are more gas-dense than the center. With time, the whirlpool effect gets even stronger. The same thing happens with hot Jupiters, which causes these gas giants to start orbiting much faster than usual. This also carries it further toward the star in a tightening spiral. Luckily, our Jupiter didn't become a hot Jupiter. Our gas giant started its life as an icy Earth-sized asteroid, which is different from the way hot Jupiters form. During the time when it was forming, Jupiter was around 4 times as far from the Sun as it is today, somewhere between Uranus and Neptune. About 2 to 3 million years after Jupiter first formed in the accretion disk of our Sun, it started a 700 million year long phase astronomers call the Grand Tack. Now, tack is something a boat performs when going towards a buoy and then slipping past and around it. Then it speeds up and goes in the direction where it came from. That was the same thing Jupiter started doing, and in its tightening orbital migrations, the planet's gravity could have moved many asteroids and other space bodies, distorted the orbits of larger planets, and caused collisions and chaos. Jupiter's grand tack would have destroyed many big space bodies. It's a could-have-been scenario, but luckily, Jupiter changed its course and became a peaceful gas giant. Neptune, Uranus, and Saturn were starting their own version of this chaotic process. Saturn even got so big that its gravity started pulling Jupiter away from its orbit. But after some time, these gas giants' orbits became locked. Then both of them managed to clear away the gases remaining between them. And since these gases were some sort of fuel for the planet's migrations, Jupiter and Saturn could both finally settle into the stable orbits we know today. Jupiter can still lob 1 to 2 icy asteroids at the inner planets from time to time. But when our planet was younger, this could have been one of the processes that formed the oceans on Earth. But Jupiter is much calmer these days. Saturn's gravitational forces have moderated the situation and are now keeping it under control. Now, Jupiter is our protector. It's 2.5 times the mass of the other planets of our solar system combined. It's some sort of a gravitational shield orbiting around the inner part of the solar system. Jupiter redirects incoming debris and asteroids away from the inner planets, Mercury, Venus, Earth, and Mars, keeping us all safe. Because of this, Earth has always been protected, so our planet has had enough time to evolve complex life forms. And it hasn't been destroyed by asteroids, hot Jupiters, or other space bodies. Jupiter wasn't the only planet that could have collided with Earth. Scientists think Mercury might have been involved in a hit-and-run accident with our planet. Mercury is the innermost planet in our solar system. It's the closest to the Sun and the smallest planet out there. And it also keeps getting smaller. Nowadays, its diameter is around 9 miles smaller compared to its size 4 billion years ago. Scientists think this might be happening because the planet's core is made of iron, and this iron is cooling and becoming solid, which is slowly reducing the planet's size. Mercury is the planet with the biggest number of craters in our solar system. Its atmosphere is really thin, so it can do nothing to keep the planet protected from meteors. The largest crater on Mercury's surface is at least 963 miles across. It could fit Western Europe from Germany to Portugal. The object that formed such a crater must have been at least 62 miles long. With all these craters, Mercury looks similar to our Moon. It orbits the Sun faster than the other planets, so 1 year on Mercury lasts around 88 Earth days. That means celebrating a birthday every 3 months or even more often. At the same time, the planet rotates so slowly that a day on Mercury lasts almost 59 Earth days, a long time to wait to go to bed. There's a piece of Mercury on our planet. In 2012, a green meteorite was found at a street market in Morocco. Scientists studied its composition and concluded it could be from Mercury. Mercury doesn't have its own moons because of its small size and weak gravity. Plus, the planet is too close to the Sun. By the way, the only other planet without moons in our solar system is Venus. Mercury has a really thin crust, like a good pizza. One of the theories of the planet's formation claims there was a major collision where the planet lost most of its crust. It could have also moved Mercury from its original spot. It wouldn't be unusual. The gas giants in our solar system also didn't form in the location where they are today. Mercury also has an eccentric orbit, which means it could have been kicked out of its old orbit and moved to a new one. Scientists also think Mercury might have collided with the early Earth. One theory says that's how the Moon could be formed. out of all the material flying away after the big crash. There might even have been pieces of Mercury's crust in the mix. Exoplanets Kepler 107b and Kepler 107c are a pair of planets that orbit a star similar to our Sun in the Kepler 107 system. It's around 1,700 light-years away from us. These planets have almost identical sizes, both with a radius 1.5 times that of Earth. But one of them, Kepler 107c, is almost 3 times as dense as the other. That's because the planets have a different composition. Some scientists believe that Kepler 107b is less dense because it probably collided with another unknown planet in the past. This powerful hit took away part of its surface and left behind a very dense core rich in iron. A huge comet hit Neptune around 200 years ago, but since Neptune isn't a rocky planet with a thin atmosphere like Mars or Mercury, it's harder to find evidence of this impact. But a comet called Shoemaker-Levy 9 broke apart in 1994 and smashed into Jupiter. Astronomers managed to record this event. It helped them learn more about the elements and molecules the collisions left in Jupiter's atmosphere. This information helps scientists realize that the amount of carbon monoxide in the upper layers of Neptune's atmosphere is higher than in the lower ones. This means a big comet likely hit the planet in the past, since comets have carbon monoxide in their icy tails. Something huge slammed into Uranus, too, changing the planet forever. A space object twice bigger than Earth hit the ice giant. This left the planet tilted, and it looks as if it's rotating on its side. Uranus is extremely cold, way colder than it's supposed to be. It might mean that the object that slammed into it was probably a young protoplanet made up of ice and rocks. Also, some of the debris from that collision may have created a thin shell around Uranus. It still traps the heat coming from the core of the planet. There are strange energy pulses bombarding our entire galaxy, and they come from the other side of the universe. Over the last decade, scientists have been observing bizarre flashes of light coming toward our planet. This phenomenon is called fast radio bursts, or FRBs. These signals travel through a couple of billion light-years of dust and gas. That's a rather long way. So far, no one has figured out what's going on behind these bursts.
All the planets of the solar system are slowly lining up. Mercury, Venus, Earth, Mars, Jupiter, Saturn, and Neptune are about to form a straight line. This event, called the Parade of Planets, occurs once every 176 years. The last time this happened was almost 40 years ago, and it was a great chance to explore all these planets in one go. On August 20th, 1977, thousands of people gathered outside NASA's Kennedy Space Center. They came to witness the launch of the most ambitious and distant space mission in history. 5, 4, 3, 2, 1, ignition! Launch rocket Titan took off from Earth and left the atmosphere. As soon as the rocket reached outer space, it launched the probe Voyager 2, which began its journey. The probe consisted of a bus 1.5 feet in height and almost 6 feet wide. On top of it, there was a round 12-foot wide antenna. Most of the scientific equipment was mounted on a boom that extended 8 feet outward. On September 5, 1977, Voyager 1, the identical space probe, left our home planet. It sent us pictures of Earth and the Moon. It soon overtook Voyager 2, launched 2 weeks earlier. That's why the second probe has the number 1 in its name. And so the journey through dark space began. March 5, 1979. About 4 Earth-Sun distances away from our planet, Voyager 1 came close to Jupiter and prepared its scientific equipment to explore the planet. The probe had a dozen gadgets, including a 2-camera system with narrow and wide-angle lenses. So, it could take full-length photos of the planet with the wide-angle camera, as well as close-up photos of specific places on the planet and its satellites. The probe also had a radio science system to determine the atmospheric composition, weight, and gravitational fields of the planets it came across. Infrared and ultraviolet spectrometers could help measure radiation and temperature invisible to the human eye. Various sensors were used to examine cosmic rays. Voyager 1 was the first to find volcanoes outside Earth. Those were on Jupiter's satellite, Io. It has dozens of active volcanoes that constantly spew lava. Then the probe pointed its cameras at the Great Red Spot. That's how people learned that it was a giant cyclone-like storm that hasn't stopped for the entire history of observations of Jupiter. It was also the first time when lightning was detected outside of our home planet. And in the invisible spectrum, Voyager 1 noticed that Io acted like an electrical generator for Jupiter. Ions, which are charged particles, were constantly flying toward the gas giant. This electrical current was 5 million amps. Soon, Voyager 1 continued its journey. 5 months later, Voyager 2 approached Jupiter too. This gas giant has rings around it. They're not like Saturn's though. Jupiter's rings consist mostly of dust. When the planet's rocky satellites collided, they turned into small debris. Gradually, this debris turned into fine dust. Then Voyager 2 approached Europa. This moon is completely covered by a crust of ice, and beneath it, there may be a liquid ocean where life can possibly exist. Voyager 2 was the first to capture the cracks in Europa's ice crust. While flying near Io, Voyager 2 discovered that 6 volcanoes on its surface were still erupting. This meant that the periods of activity of these volcanoes could last for months. Both space probes circled the gas giant several times and then dashed further into space. Such a gravitational maneuver allowed them to gain more speed and saved fuel for the trip. By November 9, 1980, Voyager 1 had already traveled 8 Earth-Sun distances away from home. The space probe arrived at Saturn. It discovered 3 new satellites of the gas giant: Atlas, Prometheus, and Pandora. This proved the theory that these were the moons that kept the planet's rings in line. It also turned out that unlike Jupiter's, Saturn's rings also contained ice. Voyager 1 took a peek at Titan, Saturn's largest satellite. It's 50% larger than the Moon and even has an atmosphere. It's the only place in the solar system besides Earth where liquid water has been proven to exist. That's why scientists don't deny the possibility of life there. Then it was time for another gravity maneuver. Voyager 1 once again darted away from the planet's orbit. This time, it was aiming upward relative to the line of the parade of planets. Almost a year later, Voyager 2 arrived there. It made a flyby of several of Saturn's icy satellites. Supposedly, a long time ago, these moons collided and knocked huge chunks of ice and rock out of each other. This debris orbited Saturn, collided, and slowly crumbled into dust, consisting of ice and rock. This is how the famous rings of Saturn were born. Another gravity maneuver, and Voyager 2 set off for the next gas giant. 5 years later, it arrived at its destination, 17 Earth-Sun distances away from our planet. For the first time ever, a human-made object approached Uranus. Voyager 2 discovered 11 new moons there. The probe also found that Uranus was the coldest planet in the solar system. Its temperature is negative 350 degrees Fahrenheit. That's 4 times colder than the temperature at the South Pole. At that time, the Deep Space Network was being tested on Earth for the first time. It's a network of radio telescopes all over the planet. They aim at certain points in the sky to establish communication with extremely distant objects. These telescopes have been successfully receiving signals from Voyagers 1 and 2. August 25, 1989. Voyager 2 had already traveled 23 Earth-Sun distances and arrived at Neptune. It was the first time people received images of this blue planet from such a close distance. The probe discovered 6 new moons there and also took the first pictures of the planet's rings. Engineers then turned off the probe's cameras to save power for its main computer and the instruments that measured the solar and interstellar wind. Voyager 2 left Neptune and headed into deep space. That's why it no longer needed the cameras. A few months later, Voyager 1 sent its last photo back to Earth. It was a family portrait of our entire solar system. Every pale dot was a planet. You can barely recognize Earth in the picture. After that, the camera was turned off to save power. This was the start of the interstellar mission for Voyager 1. For 15 years, Voyager 1 had been flying to the edge of the solar system. On December 16, 2004, the probe passed through the termination shock. This is where the solar wind suddenly slows down and heats up after colliding with the interstellar wind. The space probe managed to endure this test and continued its journey. In 2007, Voyager 2 crossed the same boundary. At that point, sensors recorded a temperature of about 266 degrees Fahrenheit, but the probe managed to withstand it and continued its journey through the dark cosmos. Both Voyagers moved through interstellar space in different directions. They discovered that the heliosphere, the solar wind bubble, is not perfectly round, but more like an egg. August 25, 2012. Voyager 1 became the first human-made object to enter interstellar space. It's now also the most distant artificial object in human history. On November 5, 2018, Voyager 2 also left the solar system. The two probes continued their journey into deep space. Right now, the Voyagers have been operational for 44 years. Voyager 1 has traveled 153 Earth-Sun distances and is moving forward at 38,000 miles per hour. In about 300 years, the probes will reach the Oort cloud. This is a hypothetical region around the solar system with nothing but asteroids and blocks of ice. Scientists believe they might reach the nearest stars in the next 40,000 years. Perhaps one day, the Voyagers will enter these star systems and explore unknown worlds. There may be planets there that look like ours. The probes may even be able to find an intelligent civilization there. For this purpose, each Voyager carries a golden record with a message on it. There are 115 images. Among them, there's our number systems, a map of the solar system and pictures of its planets, diagrams of human DNA, portraits of people, and landscapes from Earth. There's also greetings in 55 of Earth's languages, including the oldest and newest of them. There are also 90 minutes of music from every corner of our planet. The Voyagers also carry a device to play these sounds. If another civilization gets this record, their scientists could decode the data step by step. And then, that civilization may decide to pay us a friendly visit. They'll have to repeat the heroic journey of the Voyagers, though. Dozens of light years through dark space,